Nagtapos na ang 30 kababayan natin na nabiyayaan ng libreng short training course ng Aksyon ni Kuya. Nagbabalik po si Mon Hoxon.
Nagtapos na ang first batch ng mga kababayan nating sumailalim sa free training course na ipinagkaloob ng Aksyon ni Kuya Daniel Short Training Courses Program. Sila ang mga nag-aral ng kursong Building Electrician at Wiring Installation. Nagkakahalaga ng mahigit 6,000 piso ang kursong ito, ngunit libre itong ipinagkaloob sa pamamagitan ng Sophia Review Training and Consultancy. Ito ay bahagi ng public service ni Kuya Daniel na makapagbigay ng libreng edukasyon sa ating mga kababayan. Bukod sa libreng training, tutulungan din ng Sophia ang mga nagtapos na makakuha ng lisensya.
Matutulungan din po namin sila in terms of getting their license, PRC license po. Sa field po ng electrician po, ang highest license po na ma-achieve po nila, ito po tinatawag na Registered Master Electrician.
Ang mga lisensyang ito ay maaaring magamit ng mga nagsipagtapos upang makapag-apply ng trabaho sa labas ng bansa o di kaya'y sa mga malalaking cruise ship.
Sa barko po, usually po ito po yung requirement. So maganda po ang opportunity rito pag may license sila. Ang mga full-fledged po na master electrician sa barko, ang sweldo po niyan ranging from 5,000 to 6,000 US dollar a month.
Ito si Lolo Arsenio, 66 na taong gulang. Sa kanyang katandaan, nais niyang samantalahin ang pagkakataon na matuto upang kahit papaano ay magkaroon ng pagkakakitaan.
Kung may pagkakataon na makapagtrabaho, magtatrabaho pa po.
Sa mga darating na buwan ay muling magbibigay ang Sophia ng libreng training sa ating mga kababayan. Mon Hoxon, UN TV News Worldwide.
Matalik na magkaibigan sina Lola Miding at Loida. Magpinsan din ang kanilang mga asawa. Bagamat parehong nagmula sa tribong Dumagat, magkaibang wika ang kanilang kinamulatan. Si Lola Loida ipinanganak sa kagubatan. Si Lola Miding naman ay sa kaliwanagan o sa labas ng kagubatan, gaya ng sityo Nayon na 1 oras ang lalakarin bago makarating sa sentro ng barangay Santa Ines. Nang bigkasin ni Lola Loida ang halimbawa ng mga wikang ito, iisa ang diwa na nais niyang iparating.
Kalbiyan niyo kami at tabiangan. Ibig sabihin, kawaan po naman ninyo kami tulungan sa aming kakapusan, kahirapang ito. Ayun pong isa ay maiginamat din na tangka mo, ay baka matulungan niyo si kami, ay biyan niyo si kami, anay maibigay yung si kami. Ang ibig sabihin po noon, ay buti po't dumating kayo, kung kami matutulungan niyo, ganoon din. Sa kakulangan namin, ay gabayan ninyo kami.
Si Lola Miding naman, idinadaan sa awit ang pagpapahayag ng kanyang pagtitiwala sa nasa itaas.
Kung mahalaga ang buhay, dapat mong baguhin pagkat ito'y pahiram lang sa atin. Darating ang araw, ito'y babawiin ng amang lumikha sa atin.
Sa edad na mahigit 70, kailangan pa nilang magbungkal ng lupa.
Wala pong kakainin ay. Wala po namang hanap buhay yung aking mga anak. Kulang pa doon sa kanilang mga anak. Ay kung dadagdag pa ako, ay kaya ko pa namang magtrabaho. Maski pa paano, nagtatrabaho ako para hindi na ako humingi sa kanilang kita sa pagtatanim.
Luya ang pangunahin nilang produkto at ito na rin ang huli nilang ani sa taong ito. Mula buwan ng Hulyo hanggang Setyembre, ang panahon ng pagpapatubo ng kanilang mga pananim. Tuwing umaga, maswerte na sa kanilang mga bahay kung may nilagang luya na may sambong o di kaya'y kamoteng kahoy upang ilaman sa kanilang tiyan bago magtrabaho.
Ay nako po, ang hirap. Pasensya na po, huwag ko nang ikuwento ang hirap na pinagdaanan ko. Minsan po'y kumakain kami ng isang bisis sa isang araw, nilagang tubig na may asin. Opo, yan po'y talagang naigagamas namin. Pero awa ng Diyos, ay ito pa.
Ang kahilingan ni Lola Loida ay agad na tinugunan ng Members Church of God International, damay na rin ang nasa 300 katutubo sa sityo na kapareho rin nila ang pinagdadaanan sa buhay.
Ay, malaki po ang maitutulong yan. Malaki po ang maitatanim namin. Dahil gagamitin po namin yan sa pagtatanim. Pang araw-araw namin, panananim. Yung halimbawa, maghanap buhay. Makakain po namin yan para makatulong ng kalakasan. Kaya maraming salamat po sa inyo na mga kapatiran dahil ngayon po lamang namin naranasan ang ganito.
Ang mga katulad ni Lola Miding at Loida ang isa sa mga nagpapalakas ng kalooban ng MCGI upang ipagpatuloy ang pagpapakita ng mabuting gawa. Dahil nasusulat, lumiwanag na gayon ang inyong ilaw sa harap ng mga tao upang makita nila ang inyong mabubuting gawa at kanilang luwalhatiin ang inyong Ama na nasa langit.
Ipasalamat kami nun di makidifat. Tate, nagkaloob di kami at tinabihangan kami. Abinyan ni Papangan mi at kay Edo.
Ano ibig sabihin nun?
Ang ibig kong sabihin, salamat sa Panginoon at may dumating sa aming mga kapatiran na tumulong sa amin na sana'y paglayugin.
Eliseo Fernando Soriano o mas kilala sa tawag na Brother Eli. Isang Filipino televangelist at overall servant o lingkod pangkalahatan ng Members Church of God International o MCGI. Matapang,
If you can prove, você pode provar, that what I am doing is deceit, que o que eu estou fazendo é engano, I will have my head cut here. Deixa que corte minha cabeça aqui mesmo.
matalino, at prangka.
Sa relihiyon, ang pinag-uusapan na kaluluwa. At pag yan ay naipahamak mo, wala ka ng paraan para mabawi pag nakuha yan ng demonyo.
Ilan lamang ito sa mga katangian ni Brother Eli na siyang dahilan kung bakit marami ang nahikayat na makinig at manood sa kanyang pangangaral ng salita ng Diyos. Nakilala si Brother Eli bilang host ng the longest running religious program in the Philippines, ang Dating Daan. Nagintanyag siya sa pamamagitan ng kanyang mga Bible expositions na kung saan isinisiwalat niya ang sari-saring panloloko at katiwalian ng mga bulaang pastor at relihiyon.
May mababasa ba kayong talata ang kaligtasan nawawala?
Meron. Pag nabasa ko, talo ka na.
Sige. Agad ang mete. Okay. Ganito.
Eto, Mr. Moderator. Mr. Moderator, eto I am fed up. Maliligaw ang tao eh. Ito, kahuling-hulihan kong kahilingan sa inyo. Kung mabasa ko bang naiwawala, tatanggapin nyo, talo na. Tapos na ang diskusyon.
Lubos rin na hinangaan si Brother Eli sa pagsagot on the spot ng anumang katanungan sa Biblia. Sa pamamagitan ng programang Itanong Mo kay Soriano, Biblia ang sasagot.
Naintindihan ko po at maliwanag, salamat po sa Diyos. At naipaliwanag ninyo ng maayos yung kasagutan dahil marami na po akong pastor na natanong tungkol dyan. Wala pong nakasagot.
Salamat sa Diyos. Salamat sa Diyos, kapatid. Ang karangalan ay para sa Diyos na ating kinikilala at pinaglilingkuran.
I'm not offended by what you say, but I respect your words of wisdom from the Bible. I do know that God can only help me for where I've been. And today,
I want to become a member of the church. And follow the doctrine according to God's word.
Wala ni isang tanong patungkol sa Biblia ang hindi nasagot ni Brother Eli. At wala ni isang relihiyon at samahan ang nagtangkang gumaya sa estilo niya ng pangangaral ng salita ng Diyos.
Kaya nga may Bible o may Biblia, yan ang kinasusulatan ng mga salita ng Diyos na itinuro ng Panginoong Hesus. Kaya yan isinulat, utos ng Diyos na isulat yan para makarating sa atin.
Pero marami ang hindi nakakaalam na bukod sa pangangaral ng salita ng Diyos, mayroong malaking puso sa pagtulong sa kapwa si Brother Eli. Ang Members Church of God International o MCGI na inaakay ni Brother Eli ang siyang pangunahing katuwang ng UNTV sa pagbibigay ng serbisyo publiko sa ating mga kababayan. Si Brother Eli ang nasa likod ng mga public service ng UNTV na free education, free medical mission, free legal service, libreng sakay, at iba pang programa ng pagtulong sa ating kapwa.
Kahit kami po'y hirap, wala kaming pera, maliit kaming organisasyon, ito ang aming pangako sa Diyos at sa inyong lahat. Magpapatuloy kami sa tulong ng Diyos na sabihin ang aral ng Diyos sa ikaliligtas ng sangkatawan.
Tapat sa kanyang pangako sa Panginoon, February 11, araw ng Huwebes. Ito ang kanyang huling broadcast.
Gracias a Dios por sus esfuerzos, hermanos y hermanas. Somos gratos por su participación. Que Dios lo bendiga a todos.
Papuri sa Diyos, mensahe ng kaligtasan at paggawa ng mabuti at paglalakbay sa matuwid na landas tungo sa kaligtasan pa rin ang kanyang iniwang mga salita. Pinagpahinga man ng Panginoon si Brother Eli, pero magpapatuloy ang mga programa at proyekto na kanyang pinasimulan. Isang tunay na kapatid ng lahat. Isang mapagmahal na lolo para sa kanyang mga apo. Isang mapagkupkup na magulang sa mga ulila. At isang abang lingkod para sa kanyang mga inaakay. Salamat sa Diyos sa buhay mo, Brother Eli Soriano.
Pangako sa iyo, Ama, magtitiis habang buhay, tulungan.
Paggawa ng mabuti, minamadali rin. Kung paano minamadali mo ang paggawa ng masama nung ikaw ay manggagawa pa ng masama, ngayong nakasumpong ka ng mabuti, huwag kang magpatumpik-tumpik, huwag kang magpa-delay-delay, huwag kang magpabukas-bukas. Pagkakasumpong mo ng mabuti, gawin mo agad.
Mon Hokson, UNTV News and Rescue. Diyos ang aming sandigan, serbisyo publiko, ang aming pinahahalagahan.
Magandang araw po sa inyong lahat mga kawerpa. Ngayon po nandito po tayo sa bahay ng isa sa pinakamagaling nating estudyante sa Marinized Powerhouse Team Review and Training Center. No? Siya po ay dating security guard, ngayon ay isa ng electrotechnical officer. Alamin natin ang kanyang buhay. Tara po! Ber, kamusta?
Kamusta po, kawerpa? Magandang araw po sa inyo, mga kawerpa.
Magandang araw sa iyo. Ayun mga kawerpa, alamin natin ang buhay ng isang dating gwardiya at ngayon ay isa ng electro-technical officer. Kawerpang Ber, mag-share ka naman ng iyong buhay bago ka naging isang electro-technical officer.
Before ako naging isang electro-technical officer, 12 years old pa lang ako, sinasama na ako ng tatay ko sa trabaho, sa construction, para matutunan ko yung mga trabaho niya doon sa construction. So, pag may mga trabaho siya regarding electrical, nakikiusap ako sa kanya kung maaari ako yung kanyang kuning assistant doon sa kanyang electrician para matutunan ko yung mga paraan ng isang electrician kung paano yung mga ginagawa nila. After po nung sa construction, nakita ko yung ang project namin hindi gaanong tuloy-tuloy at minsan seasonal lang ang trabaho doon. At minsan may project, minsan wala. So, nag-decide ako na maghanap ng iba pang trabaho. So, ang nakita ko, ang trabaho ng isang security guard na pwede kong pasukin. So, nung naging security guard na ako, nakita ko na medyo stable ang kita doon dahil by monthly meron kang kita. Tsaka compare doon sa construction, 3 months lang yung kontrata, minsan wala, minsan meron. Bilang isang security guard, nalaman ko na hindi sapat yung aking kinikita dahil may pamilya na ako.
Bakit ka nag-decide na mag-shift ng career mula sa pagiging security guard sa pagiging electrician?
Nalaman ko na mas malaki yung kinikita ng electrician kumpara sa isang security guard, lalo na kung sa barko ka nagtatrabaho.
Kailan at anong year ka nag-enroll sa Marinais Powerhouse?
Taong 2010, pauwi ako ng bahay, may isang taong nagbigay sa akin ng flyers, nagabot sa akin. So, sa madaling sabihin, pumunta ako doon sa location nila at nag-inquire ako. Nalaman ko na ang isang high school grad na kagaya ko ay pwede palang mag-take ng board exam sa PRC bilang isang registered master electrician. Nalaman ko din na nag-o-offer sila doon ng iba't ibang training gaya ng industrial motor control, building wiring electrician at practical electrical design from residential to commercial hanggang sa high-rise building.
Anong masasabi mo sa serbisyong binigay sa iyo ng Marinais Powerhouse Team Review and Training Center?
So, masasabi ko sa kanilang service, napakaganda ng service sa Powerhouse. Lalo na yung mga teacher doon. Napaka-asikaso nila sa mga reviewees, lalo na sa mga trainees. At tinututukan talaga nila ng gusto yung mga reviewees nila. Nakagaya ko na medyo average lang ang knowledge sa pag-aaral. So, mas nagpo-focus sila at inuunawa din nila yung mga kagaya namin. Dahil alam nila na hindi kami gaanong mahuhusay. So, ang isa pang kagandahan na nakita ko sa Powerhouse, yung kanilang pag nagturo sila by the heart at talagang hindi nila kami pinababayaan. Isa pa sa nagustuhan kong serbisyo na ipinoprovide nila ay ang kanilang spoon feeding style sa pagtuturo at mga review materials, maraming review materials na ipinoprovide sila sa amin na doon maraming lumalabas sa board exam. At ang mga staff nila napaka-friendly, lalo na mga teacher.
Paano naging benepisya sa iyo at sa iyong pamilya ang pag-enroll sa NPHT Review Center?
So, simula nung nag-enroll ako, nabago yung buhay ko dyan sa Marinais Powerhouse. Dahil dyan, nagsimula ang aking pag-asenso sa buhay. At nagamit ko yung mga basic principle na natutunan ko sa Powerhouse. Lalo na yung mga itinuturo sa akin sa pagtutroubleshooting.
Sa ngayon, ano ang eksaktong position mo sa barko?
Sa ngayon, ang aking position ngayon sa barko ay isang electrotechnical officer na yung pinakamataas na rank sa ship electrician sa barko.
May plano ka rin ba mag-upgrade ng iyong skill mula sa pagiging registered master electrician to electrical engineer?
Actually, nakapagtapos na po ako ng BS Electrical Engineering, ITIA, sa Manuel Estenberga University. At sa ngayon, ongoing na po ako sa aking pagre-review sa Registered Electrical Engineer Board Exam this coming April 2022. Ako po si Virgilio Daniel Jr., dating security guard. Ngayon, isa ng Electro-Technical Officer. Kung gusto mo tutukan, mag-powerhouse ka na!
Ako'y naririto sa aking trabaho, nag-review sa Powerhouse. Tagumpay ay dala ko, pagpapakumbaba ay natutunan ko. Kahit marami ang tawag sa akin ay amo, ngayon ay alam mo na kung saan dapat pumunta. O pare ko'y huwag tatanga-tanga kung gustong makuha pangarap na lisensya. Kung gusto mo tutukan, mag-powerhouse ka na.
Tutukan, tutukan.
Tutukan, tutukan.
Sa Powerhouse, tutukan.
Sa Powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Focus ang isipan.
Focus ang isipan.
Tutukan, tutukan.
Tutukan, tutukan.
Sa Powerhouse, tutukan.
Sa Powerhouse ay tutukan.
Tutukan, tutukan.
Tutukan, tutukan.
Spoon feeding ang gagaan.
East in June, trade the brightest greens of summer for the dreams of navy blue. East in June, leave the calm Pacific breeze for an Atlantic rendezvous. 'Cause I've been driving for days.
Overwhelming po kasi to be honest, sa 8 years po ng Powerhouse, ngayon lang po nagkaroon ng ganitong event eh. First time lang. Because kasabay po nitong event na to, yung pag-launch po ng dalawang bagay po ang ilo-launch namin ngayon. Una po yung PAME, P-A-M-E-E. We call this as Powerhouse Association of Master Electrician and Electrical Engineers. Tapos po, Power Link, no? Link that makes you bigger. The intention of this is to help contractors and suppliers para ma-promote po sila sa Powerhouse family.
You're my landlocked blues. 'Cause I've been driving for days on down a dusty road.
Una sa lahat sa Diyos, naging isa ako sa mga mapalad na nakatanggap ng scholar ng Powerhouse. Napakagaling po ng mga pagtuturo dito at sana po mas mapalawak pa.
And message ko na lang sa Powerhouse, happy anniversary. Marami kayong naibahagi sa aming mga, of course, mga beneficiary na mga, of course, na mga natutunan sa buhay, knowledge, and naway magpatuloy pa yung ganitong klaseng pagbibigay ninyo ng suporta sa mga susunod na mga taon, no, lalo pat lumalaki na ang network ng Powerhouse.
My heart's tied to the coast. If I stay, I'll be a ghost. You wouldn't like me anyway.
Studio Center, I'll go by with the saying na you'll get more on what you paid for. At talaga naman lahat ng serbisyo nila ay de kalidad. Lahat ng expectation ng estudyante para makapasa sa board ay nasa isang radio center na. Ang message ko sa Powerhouse is more power and then mas madami pang blessings na umulan sa review center na ito para mas marami pang mga estudyante ang matulungan at makapasa sa board exams.
Can't wait to dive in the waves. Can't wait till I get my load. And as the sun dips down, I know no matter where my body goes, every road eventually leads me back home. Every road eventually leads me back home.
Age is just a number. Yan po ang pinatunayan ng isang senior citizen mula sa Carmona, Cavite. Ayon kay Bayan Patroller Darren Ann Manabat Morocco, proud na proud siya sa achievement na kanyang 60 taong gulang na tatay na nakapasa sa Electrical Engineering Licensure Exam nito pong September 9. Dahil sa kahirapan, napilitang tumigil sa pag-aaral noon si Tatay Renato. Sa kanyang pagpupursige, ilang beses siyang na-promote sa trabaho hanggang sa magkaroon ng sariling construction business ngayon. At may-ari na rin ng isang 4-story hotel sa Cavite. Natapos ni Tatay Renato ang kurso noong 2020 at sa wakas ay naging ganap ng engineer ngayong taon. Congratulations, Tatay Renato! Galing! Engineer!
Story, no?
Isang magandang araw po sa lahat. Ako po si Renato D. Manabat, isang RMP, at isa sa mga pinalad na makapasa sa nakaraang Electrical Engineering Licensure Examination na ginanap noong September 3 and 4. Ang lahat pong ito ay pawang may kapahintulutan at kalooban ng Ama sa Langit, Panginoong Jesucristo. Dagdagan sipag at tiyaga, dedikasyon at determinasyon makamit ang mga pangarap. Nais ko rin magpasalamat kay Kuya Reggie Marinay ng Marinay Powerhouse Team Review Center sa kanyang matyaga at masipag na pagtuturo sa amin. Sa Marinay Powerhouse, nililinaw at dinidetalye ang mga process, general principles and application nito. Nakikita ko rin ang kanyang determinasyon na makapasa ang bawat reviewee. Sa katulad kong ATF graduate, swak na swak ang Marinay Powerhouse Team Review Center. Kaya, Kuya Reds, maraming salamat. Ang galing mo. More power. At sana marami ka pang matulungan na katulad ko na ATF graduate. At sa mga regular student din, maraming salamat po.
We are one in IIE mission and vision, instilling excellence in electrical profession, having a dynamic professional association, making innovative contribution to our nation. IIE members work stronger than chain and bolt, rising to any challenge involving wires, cones and bolts. BEREE and RME, connecting industries by the electric circuits. Join us together, IIE. Join us forever, IIE. With power cords cannot be broken. Join us together, IIE. Join us together, IIE. Join us forever, IIE. Synchronize our hearts to reach greater heights and brighter lights. We serve humanity with the power of electricity, making rigid transmission quick for reliability, ensuring little power loss and high efficiency. From shifting from one place, the use of all energy. Join us together, IIE. Join us forever, IIE. With power cords cannot be broken. Join us together, IIE. Join us together, IIE. Join us forever, IIE. Synchronize our hearts to reach greater heights and brighter lights. There's only one institute, no one else can substitute. There's only one
Our speaker mentor for today is a graduate of Bachelor of Science in Electrical Engineering, batch 1996 at University of the East, Caloocan. He earned units in Master of Science in Electrical Engineering, major in Power Systems at University of the Philippines, Diliman, and Master in Construction Management at University of the East, Manila. Former cadet engineer, in-phase industrial construct, former project engineer, Security Bank Corporation, former electrical consultant, Brown Bauhaus Architecture Studio, former training consultant, Meralco, former training director, PAMAV Training Institute, former CPE lecturer, IIEE, WESM, PAMAVTech, former electrical engineering regular faculty member, UE Caloocan, also former electrical engineering faculty member reviewer, Mapua Institute of Technology, Pamantasan ng Lungsod ng Maynila, Adamson University, Rizal Technological University, Technological Institute of the Philippines, Manila and Quezon City Campus, Perpetual University, Las Piñas and Molino, Cavite, Technological University of the Philippines, Taguig Campus, and Pamantasan ng Lungsod ng Valenzuela. He is a registered electrical engineer and a registered master plumber. Ladies and gentlemen, the president of Marinay's Powerhouse Team Review Center, let us all welcome Engineer Reginaldo Kuya Reg Marinay.
Okay, good afternoon once again, aware pa. Magandang araw po sa inyong lahat and good day, good afternoon everybody. So we are here to discuss our part 2 of the topic. We discussed last time about energy saving through power factor correction. So this is already part 2 of our topic. We welcome everybody for this free webinar. This is a free webinar being conducted by NPHT Review Center, brought to us by UN Television, their public service channel, and CGI, the members of the Church of God International, and IIEE, Institute of Integrated Electrical Engineers of the Philippines. So we welcome everybody for this free webinar. So this is actually an English version of our previous webinar we conducted before in Filipino, but this time we'll be conducting our webinar topics in pure English. So this is also to help our electrical students and practitioners as possible, all over the globe, because there are some non-Filipino nationals that they are watching our video on our YouTube channel. They are requesting for the English version of our videos. So this will be our first time. Actually, this is the first topic that we are going to conduct a pure English lesson on this topic, the energy saving through power factor correction. So although from time to time we'll be using a little of our language just to add spice for the Filipino audience, because still majority of students watching us are Filipino, but there are some non-Filipinos who are connected to our Zoom class, to our YouTube Live, our Facebook Live, and maybe in the future, they will see this the uploaded video of this lecture in our YouTube channel, and of course the possibility that other nationality or non-Filipino students and practitioners would watch our pre-recorded videos. And we are doing this because we want to help also our students and practitioners, not only in the Philippines, but of course around the globe as possible. So that if you are, say last time we have a Malaysian, he is a Malaysian student, and there are some Indian Indian students giving us a message. They are asking us if there are some English version of our lecture. So this will be the first topic, and starting to this topic, actually we started last week for the English version of our lecture. Okay, so we are doing this to help everybody, okay, not only Filipino students and practitioners, but to all, no? You are Filipinos, you are Asians, you are Americans, Europeans. So as long as you understand the English language, no? And I have to apologize that I am not that well versed in using the language. So I just have a basic understanding and knowledge and communication skill in the English language. So we just want to help our students and practitioners. So please bear with us, no? Maybe possibility is I can make use of some wrong grammar or some wrong term. So we apologize for this, no? Because we are using Filipino language and English language. Although here in our country, our educational system is also in Filipino and in English, and I believe that our Filipino audience would understand also the pure English language. So although from time to time, again, I'll be using some a little Filipino language, but for non-Filipino students, practitioners, it's no problem because our base language, no, so just absorb what I'm saying in English, so you can understand easily the topic. Okay? It's just an additional, it's just an added spice on our discussion if I'll be speaking some Filipino language. Okay, so and it's like, let's say I am this Filipino students and practitioners. I call them as our kawerpa, no? Kawerpa. If you hear the word kawerpa, it simply means they are our brothers and sisters in profession, in electrical profession. Okay, kawerpa. Okay, so okay, let's start. No, so this is already part 2 of our pre-webinar on energy saving through power factor correction part 2. Once again, my name is Engineer Reynaldo Kuya Reg Marinay. So we can now start our topic. Okay, so why we improve the low power factor? Okay, low power factor means poor electrical efficiency. So poor electrical efficiency, so we have discussed this last time. The lower the power factor, the higher the apparent power drawn from the distribution network. Okay, again, the lower the power factor, the higher apparent power drawn from the distribution network. We have already discussed this before in our part 1 that the power being taken from the utility company, you know, it's not a real power only, it's not the Q only, the reactive power, but it is the S, it's the kVA. So if you have a high power factor, the higher the power factor, you have the high power factor, the lower you get the apparent power. Okay? So in here, the lower the power factor, the higher apparent power. It's also the same thing as saying as the higher the power factor, the lower the apparent power drawn from the distribution network. And that is the advantage of power factor correction. So manufacturers are often billed by their electric utility for having large inductive loads at their facilities. Inductive loads require storage of energy in the magnetic field. Again, we discussed this before that we need the Q. We need the reactive power so that to sustain or maintain the magnetic field. And magnetic field is very important in the operation of our machineries, our motors, generators, transformers, even our circuit breakers, even our relay. The magnetic field is really very important. And for the magnetic field, no, be maintained, we need this power. That is the reactive power. No? That is the function of the reactive power. Okay, which occurs in the coils of the wire. Magnetic fields occurs in the coils of the wire, such as in motor windings. Okay, if there are motor windings, if there are coils, there are magnetic fields. To decrease high electricity bills resulting from this large inductive load, capacitors may be installed at the facilities to increase the power factor. So this is the remedy for low power factor is to connect a capacitor in the facilities to increase the power factor. Okay, these are some advantages of having improved power factor. Although the number one or the greatest contribution of power factor correction is saves money, saving money. Okay, this will cut your electric bill if you have a high power factor. A high power factor eliminates utility power factor penalties. So there are utility company if you go lower than a certain base power factor. Let's say here in our country, the biggest electric utility company known as Meralco, they have an 85% maintaining power factor. So a certain building must maintain that 85%. So lower than 85%, there will be penalty or surcharge. Then higher than 85%, there will be discount you can get from the utility company. High power factor reduces the power and heating loss of the transformers and distribution equipment, prolonging life of the equipment. Okay, again, so if we have a high power factor, this reduces the power losses. If you reduce the power loss, you reduce the heating losses. We discussed this before because you will take lower current. If you have a high power factor, you take low current. Okay, we discussed this before with our current high and end. Then later we will discuss that again when we go to the discussion and applications. So high power factor means high efficiency. Okay, of course, if you reduce the power losses, the efficiency will be high. High power factor stabilizes voltage level. So voltage stabilization simply means that the fluctuations that we have, for example, in the board, go to the board. So if you have a certain fluctuations, let's say you have a base here of 230 volts, the system here becomes low voltage. It becomes low voltage. And the system here becomes high voltage. High voltage. Let's say this is a 230 volts. Low voltage, high voltage. But if you have a capacitor in the system, it stabilizes. It produces some sudden spikes or increase or decrease of the voltage. So if you put capacitor on the system, so it's more constant. Although still there is a little fluctuation, but it becomes more stabilized, more constant. Okay, so the sudden increase will be removed. So you will see here. So the increase in voltage here is reduced to this value only. It reduces. Okay, so it improves machine performance. Of course, if you have a high efficiency system, no? So the system, the line, and also the machine becomes efficient. You have your motors, your generators, your transformer, they become more efficient. If you hear your transformer, there are some hissing sound, no? So maingay siya, no? Maingay. You have some hissing sounds, you know. So meaning, so you have a low power factor. That's one cause that makes the current higher. Increase system capacity. If you have capacitor in the system, it increases the system capacity. What do you mean by this? What do you mean by this? Let's say, you, for example, you have two buildings. Say you have building A, you have building B. For example, you have an electric bill. You have an electric bill. So, let's say the electric bill here is 1 million pesos per month. That's the electric bill. What's the difference between the two? This capacitor is without, this building is without capacitor, this building with capacitor. What's the difference? So there is no difference because both of them is 1 million pesos as their electric bill. There's no difference. So the difference here is building B carries more load. They carry more load. If you put capacitor on the system, we had said last time that it is a reactive power generator. It delivers a certain reactive power. And this reactive power saves money. This simply means that you can increase your load because capacitor delivers reactive power. This is also known as the reactive power generator. This capacitor box. So they have, this building has more load. No? This building has capacitor box with capacitor. This carries more load compared to this building. So that's the difference between the two. Well, of course, if they have the same load, this will have a lower electric bill. Let's say if this is a 1 million peso, this is something like can be 900,000 or 800,000. That will be the comparison between the two.
Hello, sound check. Hey, do you hear me guys? Do you hear me? Rinig po ba tayo? Okay, may we interrupt you for a while, no? Okay, good afternoon everybody. So, well actually that is our latest, no? We just recorded that lecture just last Friday, no? We recorded this lecture video last Friday. So this is an English version of our free webinar, no? May we remind everybody to please, you're not yet finished, no? Kung hindi niyo pa po nagagawa yung inyo pong e-registration, no? Your e-registration form must be direct message, no? It should not be sent to everyone, please. This is to protect your privacy. So I don't know if they can erase that. Oh, pwede ba yan? I don't know if you can erase your. You're always announcing that every week, every Sunday. You should not send
to everyone. Please send to direct message, no, to Reginaldo Marinay. Direct message lang po ang gawin po ninyo. Kasi po ay may mga mananamantala pong mga tao na ginagamit po yung aming pangalan. Tapos kung interested kayo mag-enroll, nagbayad kayo sa mga maling tao. So it's not legit, no? May mga ilang instances na po kami na ganyan. Kaya tapos pati po yung inyong pangalan sa Zoom, no? Please replace your Zoom name by just your nickname or any decent code name, pwede na po. Huwag pong full name, no? Kasi nagkakaproblema po tayo sa mga ibang tao diyan na iba po ang intensyon, no? They are joining our free webinar but they have a different intention. This is for your safety, to protect your privacy. Please follow our instructions and please open your camera. We require open camera. If you do not open your camera, we are sorry. We will remove you. No? Kahit isa, dalawa na lang ang matira dyan. What's important, we are following our rules. You will be removed. No? We will give you the last 5 minutes to open your camera. If you will not open your camera, we are sorry. You will be removed in our Zoom class. No? Please don't take it personally. This is just our job. Ano po? So please open your cameras. If you do not open your camera 5 minutes from now, you will be removed. You will not get your e-certificate. And this is just initial registration. You're going to send that in our direct message, not just a direct message. And then later, before we finish our topic, we still have a final registration form. We have a Google form. So we have 2 registration. We have initial and the final registration. You have to send that. You have to make that e-registration form, the final registration. No? So please do not leave if the topic is already finished. We still have time. We can make some question and answer portion. You can make it a live question and answer portion. So right after the topic. I think we still have time after the topic. This will be finished at around approximately 4:30 p.m. or before 4:30. Just a little past 4 p.m. And then after that, we can have some Q&A portion. You can chat your questions, no? And I will answer that later, no? Live. We'll make some live question and answer portion. And after that, we'll be having our marketing presentation. Okay, then our final registration. So please bear with us. Please open your cameras. Okay, and let's continue. Okay, so this is what we mean here in our PowerPoint, is that it increases the system capacity. The system capacity tends to increase if you have this capacitor pumps. Okay, let us make some refresher on this. So let's say you have a motor. Let's say you have a motor being supplied by the source. So let's say you have a motor here being supplied by the source. So this is the motor current. The current taken by the motor is this one. That is the motor current. And the motor current can be break down into two. This, let's say, this one. If we are to project this in the y-axis, so you will have what we call the magnetizing current. And if you are to project this on the x-axis and this value, is what we call the working current. Some books call this as the working current. One. So that will be the two components. As we take a look, if we put capacitor in parallel with the motor, okay? If we put capacitor in parallel with the motor, okay, let's go here. Say this is the motor. Okay, let's say again, initially the motor takes the motor current. Let me say this is I sub M, the motor current. The motor current is this one. This large current here, that large current. If we put a capacitor in parallel with this motor, okay, this capacitor would draw a leading current. But take note, this is a lagging current, this is a leading current. Leading current. So that is what we call the I sub C. So there will be two current now. So at this node, there will be a current flowing here. This is our IP, which is the I total. I total. So as we see this one, no, by Kirchhoff current law at this node, the Kirchhoff current law here is, of course, the total current is equal to IP, simply equal to I sub M plus IC. That is our equation for our IT. So IT is the combination of the motor current and the leading current of the capacitor. Take a look here at the vector diagram. The motor current is lagging power factor. That is why it is downward. That is lagging power factor. That is downward. And the capacitor current is upward. See this one, that is upward. So if we are to project this size, let's say this is 3 inches. I will project this here. You see, this is our IC. That is our IC. Okay, this is IC, this is I sub M. Then, from tip to tail method, what is this current? What is this current? That is our I total, which is the vector sum of the motor current and the capacitor current. Okay? But you will see here that IT is lower than the motor current. So this current decreases. This motor current can be represented by any total current of the building. If you put capacitor on the system, this will draw a leading current here. So this leading current, okay, will make the magnetizing current, the value of the magnetizing current, this will decrease from this value to this value only. So that decreases. So bumaba siya. Okay? That decreases. So, this will be our total current. So as you see here, it reduces. Let's say, initially, let's say this, let's say 100 ampere. But here, let's say approximately this is 90 ampere or 85 ampere. It depends on the value. This one. See, it's obvious that this current decreases when you put a capacitor current here. Because this current is a leading current. Okay? So leading kasi yan, nasa taas yan. Oh, that is a leading current. Now, let's take a look here. As we see, there is a motor here. This motor, it draws total current from the source. See? So this draws what we call the working or real current. This is current for the power. Working current or the real portion, the real current, the red one, and the green one is the reactive current. This one, the magnetizing or the reactive current. Okay? one. Initially, it took these two type of current, the magnetizing current and the real current. But when you put capacitor on the system, take a look. Well, of course, this is an ideal discussion for the power factor correction because you will see here that the color green, which is the magnetizing current, the reactive current, all reactive current is being delivered by the capacitor. That is what I mean ideal. But in reality, what I can say is still the source delivers reactive current, but it lowers, it decreases some reactive portion of the current here because of the capacitor current, which is the reactive current of the capacitor. You'll see here. Okay. Okay, so this is now the motors and other loads. You'll see here that from the generation side, transmission, distribution side, no, it delivers the two type of current. And also, I would say power, because power, again, when we discussed this last time, there is a certain power being drawn by the load. Say you have a building, it's just for representation, whether it is single phase or three phase. So this grows, again, SL, what we call the SL. Again, let us draw SL. Our SL is this. Let's have some review of our discussion last time here on this portion because this is very important. So this is SL. Okay. We can break down this into two components. These are the two components. So this will be this component that is the real power, PL. And this component is our QN. That is our QN. We can also project this QL here. So we can put here QL. And if we put capacitor in parallel with this load, we can see here that this, okay, you can see here that this capacitor, this grows reactive power QC. And that QC is a leading power. That is Q of the capacitor. Let us project this dimension here. Say that is 3 inches. So this is SL. So this is our QC. And this is SL. Then this will be our ST. The vector sum of SL and QC. This is our ST. Again, we can also make use of the Kirchhoff current law at this moment. Although it is a power, but we can also make use of this. This is our ST, that is equal to SL, then plus QC. Okay, the vector sum of SL and QC is the ST. But where is the ST here? You can take a look here. This will be our ST. There you are. That is our ST. See? Let us have some angle here. So this is our theta L. This is our theta T. By the way, we can break down this ST into two components. What are these two components? So the two components are QT, one, QT, and the PL is equal to PE. Okay. Actually, we discussed this before already last time. We derive the equation, we come up with the equation of Q of the capacitor is equal to P of the load, so multiplied by tangent theta L minus tangent theta T. This is the formula in getting the reactive power in K bar. See, this is in kilowatt, and this is now the old angle, which is the theta L, and this is the theta T, which is the new angle. Some books they use PL, P of the load. They uses tangent theta old minus tangent theta new. Okay, so this is this formula to calculate the K bar of the capacitor. Okay, that is the formula. That is the formula. Let us have QC that is equal to B squared. Okay, voltage at the capacitor square. Let's say whether it is single phase or three phase. For this case, this supply voltage P is also our V sub C here because they're just in parallel. So V sub C, that is also V sub C squared over X sub C. Also, from direct current circuit, so we have here our power that is equal to V squared over R. It's almost the same principle, right? V squared over the resistance. But for this case, V squared over X. Because this is Q. If that is P, that is R. If this is Q, this is X. Okay? Now, the QC, we have V sub C squared 1 over X sub C is 1 over 2 pi FC. See this one? Then what will happen? Of course, this will go up algebraically. So we have here, 2 pi F. Okay, this will go up here 2 pi F, then C, and then V sub C squared. Okay, so that will be our formula now. Okay, it's 1. Because X sub T is 1 over 2 pi FC, although our 2 pi F is our omega, right? That's our omega. So this will go up here, so that will become 2 pi FC multiplied by V sub C squared. Okay? So I have a little technique, no, so that we can easily understand this. So 2 pi, basically 2 pi, of course, 2 is a number, pi is also, there's an equivalent number, 3.1416. So it's simply a constant, right? It's a constant. So this is Q sub C that will be equal to A, then the frequency, and then the capacitance, and the voltage of the capacitor. Okay? So that is also a formula in getting the K bar of the capacitor. No? The constant and the frequency, so you have the capacitance. This is the capacitance. And the farad, microfarad, millifarad, no? And then the voltage, okay, at the capacitor. Okay. Okay. So this little technique, no? So, I'm sorry, this is in Filipino. In Quezon City, there is KFC. there is KFC. In Quezon City, there is KFC. And also in Vito Cruz. Vito Cruz in Manila, in Lasal, partner in Lasal. Okay. So, well, of course, KFC is known all over the world, right? Okay. So, in Quezon City, there is a place in Manila, Metro Manila, that is equal to KFC. And also, there are many KFC. There are also KFC in Vito Cruz in Manila. Okay. So, you didn't get that? Forget it. Okay. So, let us go here with our PowerPoint. Let's continue. Again, if we are to take a look, a motor, it draws the two current or power. Let's go with the power. So, it gets real power and reactive power. Okay? The real and the reactive power. And then, if we have a capacitor in the system, this delivers reactive power. Of course, that reactive power delivers reactive current. One. See? Although again, I'd say that this is quite ideal because what you are really getting from the source is not only real power. There is still a small amount of Q. Again, we have to take a look here. If you don't have a capacitor, you draw this one, SL. You get PT, PL, and QL. If you have capacitor, you draw ST. And this ST, you draw PT and QT also. You are also getting a smaller amount of Q from the source. Okay, this is a more realistic. Okay, that is more realistic. Okay, it's just that you are also getting Q from the source, but it decreases. Originally, you are getting QL, but if you put capacitor, it delivers a certain value, a certain amount of Q. That is why if you put capacitor on the system, the QL will be reduced to QT. Okay? I hope you are getting me. No? Okay? Nakuha po ba ako, mga kawerpa? Nakuha ba tayo ng ating mga estudyante? Okay? Okay, salamat. No? Thank you. Let's continue this one. Okay, these are possible location of the capacitor where you will put this capacitor banks. The following are possible locations where the power factor correction capacitors can be installed. Okay, number one, at any point past the metering. Usually at the service entrance switch gear. So let's say at the service entrance switch gear, if you have, let's say, a primary metering, you can put your capacitor here. As we see here, this is a three-phase capacitor, can be connected in Y or delta. No? So actually, this free webinar is just a glimpse. It's just a what we call the a bit of the taste. Ano ba English ng patikim again? So this is a little taste of our special webinar. So we have a special webinar on power factor correction. There we will discuss fully power factor correction, especially the calculation, how are you going to size, with this certain building, what will be the size of this capacitor. So, okay. So, primary metering here. This one. This is the transformer. And there is a secondary metering here. The secondary metering, so there is a capacitor here. See, there is capacitor connected here. Okay, number 2. In electrical centers for power feeders divided according to capacitor requirement. So, as you see here, there is no primary metering here. There is no primary capacitor banks here. So we have now the secondary capacitor banks. Okay. And then number 3, possible locations at the terminal of each motor. let's say you have your large motor, so you have your capacitor here for inductive load producing a piece of equipment that is near to the motor. So you will see this capacitor that is nearer. Actually, it's really very near to the motor. Okay. Okay, let us have some practical discussion on the power factor analysis. Okay, I'll be discussing this. This may not be updated, no? We just want to discuss the basic principle of how electric bill is being reduced. So, it's power factor analysis. Let's say, okay, so we have the customer name, XYZ customer. Okay, let's say there is an average kilowatt consumption, kilowatt hour consumption. Let's say they have this 1,000 or 1 million. Okay, we can see this on the next slide. Demand. So this is 2,000 kilowatt. 2,000 kilowatt. And load power factor 0.6944. Average power factor is 0.7. And then some other details here. Let us go with this one. Can you see the presentation? Okay, it's larger already. So, okay, after your calculation, let's say, you make some calculations. No? Let's say your recommended capacitor K bar is 1,755. No? And they see this 1,755. Yes, no? Especially if you have your computer, your personal computer. Quite hard if you have your cell phone. If it is in cell phone, can they still see this one? Okay, yes, definitely. So, the two columns now, so this is the existing based on the average 10-month data. The power factor is 70%. This one, 70% power factor. Again, if that is 70%, meaning you will have a penalty or surcharge here because this is lower than 85%. So this is an example in our utility company here in the Philippines. The largest utility company is known as the Meralco, the Manila Electric Company. So they impose 85% power factor. You have to maintain that. Okay, if you go lower than that, there will be penalty. If you go higher than that, there will be discount. So, and then we have the expected. This is what we want to get. The new power factor is 99%. You want to have a 99% power factor. This is an idea. No? Although I've discussed to you last time that the idea of power factor is around 92 to 96. That's more practical. No? So again, so you go higher than 85%, it becomes 99%. So therefore, you will have a discount here, big discount here. Okay, let's break down this one. So we have the basic charge, let's say. This may not be updated. Of course, it's not updated. I just want to discuss the principle, how electricity bill is being reduced. Okay, so the basic charge, demand charge, let's say 220 pesos or any amount in your country per kilowatt. Okay. So actually the kilowatt demand is, actually this is 1,000. The average kilowatt consumption is, this is correct, this is 1,000. It's not 1 million. That is 1,000. Okay, so let's say the demand is 220 per kilowatt. Oh, by the way, it is in kilowatt. Sorry. A kilowatt is how much? That is the demand. The kilowatt is the demand. Okay, this is the kilowatt demand. No, 2,000. So what you will do here is 220 pesos. No, you have to multiply this by 2,000. 2,000. Of course, that will become 440,000. Okay, sorry, there is a little typo error here. So that is 440,000. Also, this is for 70%. That is for existing. And our expected is also the same, 220 times 2,000. That is 440 pesos. Energy charge. Let's go with energy charge. Okay, there. I think there's a mistake here. Some typo error. This average kilowatt consumption this is 1 million. This is not 1,000. This is 1 million. Because it's 1.85. The energy charge is 1 peso and 85 centavo in that is per kilowatt hour. No? Per kilowatt hour. Okay. So you will see here that this is multiplied by 1 million. So that will be 1,850,000. And also the same for the 99% power factor. 1,850,000. Let us get the total basic charge. We just have to add the two, the demand charge, the energy charge. Okay? Demand charge, energy charge. So that is around the 2.29 million or 2,290,000. They are just the same. Lower or higher than 85%, they are just the same. Just stay there and relax. Okay? So we are not yet through. We're not yet finished. Okay. So primary service discount. For example, that is 3%. 3% of the total basic charge. So is correct. So if you have 2.29 million, so I have my calculator, 2.29, let's say. Okay, this is actually 68,700. Let's say the primary service discount. Of course, this may vary, depending on your utility company. So 3%, of course, the same, 68,700 pesos. Special discount. There's no special discount. Okay, here. Now, this is the highlight. This is the highlight. The power factor adjustment. You'll see here. Where did we get this 9% here? Saan nakuha tong 9% na to? Remember, the base is 85%. 85 minus 70. 85 minus 70. Okay. Again, the base is 85%. If you go higher than 85%, you will have your 0.6% discount. This is for every percentage point higher than 85%. Okay. And if you go lower than 85%, I'm sorry. This is just 0.3. The 0.6 is in here. This is what we call the penalty, or what we call the surcharge. So this is now 0.3% discount for every percentage point higher than 85%. This is 0.6% penalty or surcharge. 0.6% for every percentage point lower than 85%. Meaning the utility company here in Manila, they want us to maintain this power factor. Okay? And power factor is synonymous to the efficiency of the system. If you have a high power factor, you have a high efficiency. If you have low power factor, you have also a lower efficiency. Let's continue this one. So why this one becomes 9%? How did you get that? So you just have to subtract 85% to 70%. 85 minus 70 is, you have first to put the 85 and then minus the existing power factor, which is 70%. So that is obviously 15. Okay? So there is a 15% in power factor, no? Lower than 85%. So what is the unit of this 15%? That is percent. And let us multiply this for the power factor adjustment, which is 0.3 or 0.6. 0.6 because this is a penalty or surcharge. So 15% multiplied by 0.6. There you will come up with 9%. Okay? Did you get that? Mga kawerpa, nakakuha mo ba? Is that clear? Okay. So this is 9%. Okay, that is 9%. Okay. So again, 85 minus 70, 15, and then multiplied by 0.6. So therefore, the penalty is 9% of the total basic charge. So if you have 2.29 million or 2,290,000, that is 2,290,000. Then we have to multiply this by 0.09. Yes, that's correct. So some typo error here. It should be 2 zeros only here. So that should be 206,100 pesos. One. Okay. Remember that this is discount and this is penalty. Again, this is discount and this is penalty. So meaning they are opposite to each other. They are enemies. You see? So this is discount. This is penalty. Dito mababawasan yung bill mo. Dito madadagdagan yung bill mo. Okay? So what you do here is not to add these two because this is discount, this is penalty. You just have to subtract these two. Let us subtract these two. So 206,100 and minus 68,700. That is equal to 137,400. Yes, this is correct. Just put a comma here. That is 137,400. Question. Is this a discount or a penalty? Partner, what do you think? Is this a discount or a penalty? Because the 3% is the discount. The 9% is the penalty because this is 70%. That is lower than 85%. And I subtracted the penalty to the discount. So we come up with 137,400. Question. What is this 137,400? Yes, very good. This is the penalty. Because penalty is higher than the discount here. Okay? Now, let's go with the new power factor, the 99% power factor. We have the 3%, again, anyway, they're just the same, 68,700. Let's go here. This is actually the power factor adjustment here. Sir, where did you get the negative 4.2% here? Where did you get that? Okay. So, the negative 4.2 is, again, if you have your 99%, again, you have your 85%. You have to subtract this by 99%. Okay. So that will be negative, right? That will be negative. So So 85 minus 99, that is negative 14%. And then you have to multiply this. No? This is a discount. That is a discount because this is 99% and the discount is 0.3%. So you have to multiply this by 0.3%. So you have your negative 14 times 0.3. So you will come up with negative 4.2 still percent. That's why you have your 4.2%. Did you get that, mga kawerpa? Did you get that, everybody? With your thumbs up? Okay, thank you, thank you. So, 4.2% of what? Still, of our total basic charge. So, that is amounting to 96,180 pesos. Now, see? Fine. So, this is a discount, primary service discount. This is also a discount. What you will do here? Are you going to add or subtract? Just add because they are both discount, right? They are both discount. If you have to add these two, that will come up to be 164,880. You see here? 164,880. Now, this is a discount. That discount must be deducted to the total basic charge, the 2.29 million. If you are to subtract this 164,880 to 2.29 million, so you will come up with 2,125,120 pesos. See? Because this is a discount, you already deduct from 2.29 here. From 2.29 million to 2.12 million. So it reduces, right? Because your power factor is 99%, higher than 85%. Now, take a look here. Again, since this is 70% power factor, again, what is this 137,000? Is that a discount or penalty? Penalty. Okay. Therefore, if that is penalty, are you going to deduct this to the total basic charge or add? You, partner, what do you think? Very good. You have to add 2.29 million plus 137,400. That will come up to be 2,427,400 pesos. That is what we call the net basic charge. Now, let us stop here. The net basic charge, if you have 70% power factor, is around 2.42 or 43, to be round off, million, 427. That is the net basic charge, 2.427. For 70% power factor, that is 2.427. For 99% power factor, the net basic charge is 2.125, which is lower in the 99 or 70%. Obviously, in the 99%, that's the big difference. That's the difference. The net basic charge here, this increases because of the penalty here. Okay? And this reduces. On the other hand, this reduces because of the discount imposed by the utility company. See? Then, let's go to the net basic charge. This is the net basic charge. For 70% power factor, let's say the SERA or the current exchange rate adjustment, this is on the government side. So 6% of the net basic charge, the 6% of this is 147,644 pesos. And then the 6% for the SERA or current exchange rate adjustment is 6% of this, which is 127,507.2. Then there is a purchase or power adjustment or the PPA. The PPA is 3.28 here multiplied by 1 million. So this is around 3.28 million. Okay, in here, so of course, they're just the same, 3.28 times 1 million. So we have here 3.28 million. See? Now, we just have to add the last three, the net basic charge, the SERA, and the purchase power adjustment. Let us just add these three. For the 99% power factor, if we are to add these three, we come up with 5,532,627.2 pesos. Okay? Or simply 5.5 million. For the 70% power factor, if we have to add these three, 1, 2, 3, so this will come up with 5,853,044 pesos. You see, this is 5.85 million against 5.53 million. Which is lower? 70 or 99%? Of course, on the 99%. You will see here a difference between the two, 5.8 against 5.5 million. More or less, it's around 300,000 pesos, right? To be exact. Okay. The present bill, let's say, the projected is 5.8 million. Less the expected bill, because you increase the power factor, 5.5 million here. The monthly savings is around 320,000 pesos. Okay. What is 320,000 pesos? Although this is not updated, no? But still today, in year 2022, what is 300,000 pesos? You can buy a second-hand car with 320,000 pesos. You can buy a second-hand car. No? Say a Mitsubishi brand. If you want to buy Toyota brand, you can buy with this amount. That's big. The 300,000 pesos is. No? This is already a salary of a maybe a CEO in a company or a big manager, no? In a company. So this is a big discount, a very big discount. If we have to multiply this by 12, no? The annual savings for 1 year is 3.845 million or 3.84 million. What is 3.84 million? It is already a house in our country. Maganda-ganda na yan. It's a big luxurious house in our country. Okay? So you see, in 1 year, you can buy a house. Because of your savings in the power factor correction, right? I remember my student, he is selling a capacitor banks. No? Their company, the deal of their company is do not pay us, use that first. And then if you see a discounts, then you can pay us. If there is no decrease in your electric bill, do not pay us. Do not pay. We'll get our capacitor banks. We'll give you 6 months. We'll give you 6 months. In that 6-month period, you will see the improvement or the decrease in your electric bill. You see? Let us say a conservative, during this time, although this is not updated, based on the highest estimated of 1,000 pesos per K-bar, or simply 1 peso per bar, right? Let's say your calculated is a 1,760 K-bar capacitor. So whatever the value, from the formula I've showed to you, this one, take a look here, partner. Okay, this formula, you will see this formula, no? This is the formula in getting the K-bar of the capacitor. Again, let's say the capacitor cost. You will buy this capacitor box from the supplier. So this is 1.76 million pesos. 1.76 million pesos. This is already a house in our country. Sir, that's too much. 1.76 million. Okay, let's take a look here first. So you have 1.76 million. You buy capacitor box amounting to 1.76 million pesos. But you have a monthly savings of 320,000 pesos. You have to divide this 320,000 pesos to 1.76 million. If we are to divide this 1.76 million, the amount of capacitor bank, that is the price of the capacitor bank. You divide this by your monthly saving, which is 320,000. You will come up with 5.5 months. This is what we call the payback period. What do we mean by payback period? In just 5.5 months, you can get the price you spend in these capacitor banks. Kumbaga, bawi mo na siya. No? That will be returned to you. It's something like an ROI, the return of investment. In just 5.5 months, all your 1.76 million will return to you, to your company, as a saving. That is what we call earning through saving. See? No? Matipid ka lang, kikita ka na eh. Pag tipid ka. No? Kung magastos ka, lagi ka. Malugi ka pa. No? So, you see, there is 5.5 months as your payback period. Okay? So, babalik na kagad yung pera mo sa loob lang ng 5.5 buwan. Okay, by the way, to our non-Filipino audience, so I'm speaking a little of our language, no, but don't worry. So just mind all the English sentences I'm delivering to you, no. So you can understand fully this topic, no. So it's just an added spice on the discussion. That's why I'm saying some Filipino words or language. Okay, so in just 5.5 months, that will be returned to you. Your investment will return to you through saving. Okay? And of course, no, if you have a very good maintenance program on your capacitor bank, no, that would last for many years. That would last for years. Okay? So, and that will be your savings, okay, for so many years. This really gives a lot of advantage. Okay. Okay. How does Meralco? Meralco is the utility company here in Manila. How does Meralco implement discounts on improved power factor? So, through power factor improvement, power utilities realize more effective use of power facilities and reduce power distribution loss. Even in the system of the utility company, it gives a lot of advantage. Even utility company make use of power factor correction. They have this capacitor bank. No? So, being put on the pole, so of course also for power factor correction. Because the utility company also pays their bill to the transmission company or a generation company. But because of this benefit, power companies pass on the savings to end user in the form of lower electricity charges. In the case of Meralco, a discount structure called the power factor adjustment is done. Should the average monthly power factor of medium and large customer be less or more than 85%, the total basic charge, excluding other discount, are adjusted as follows. Again, this is my basis for the 0.6 and 0.3. 0.6% surcharge for every percentage point lower than 85%. 0.3% discount for every percentage point higher than 85%. So this is my basis. Okay? So, sir, why is that, if that is discount, it's only 0.3. But if it is a penalty or surcharge, it is 0.6. Isn't it unfair? That is business, you know. Negosyo yan eh. Wala tayong magagawa. No? We can't do anything for that. It depends on the utility company. Okay, let's have an example. Okay, I already, of course, you cannot see this clearly, no? I just have to put this one. Take a look here. There is a multiplier here, 3.96. Where did he get that? Remember, the power factor, initial power factor here is the initial power factor here is 78.4%. One. Okay. The initial power factor is 78.4%. So again, if we are to multiply this 78.4%, no, let us subtract this first. That will have a penalty. No? Then, this is a full exaggeration, ano? It increases to 100%. Let's go first to the 78.4%. If we have here 85, again, percent minus 78.4%. Okay, so let us subtract that one. So that will be 85 minus 78.4 equals, that is 6.6. Correct, 6.6. Then, of course, that is penalty. That is penalty. You have to multiply this by 0.6, right? 0.6 times 0.6, that will be 3.96. So you will see this is the 3.96. Although you can see this clearly, no, that is the 3.96. Then multiply here. So there's a certain amount, no? So the net basic charge, okay, 3.96 for the power factor adjustment, I mean. So we'll come up with the penalty of 11,578.7 pesos. Okay. Let's go with the 100%. Since the 100%, again, we have 85% minus 100. Of course, that will become negative, right? That will become 15, negative 15%. And then we have to multiply this by 0.3. So that is the discount, right? For every percentage point higher than 85%. So that is 15, then multiplied by 0.3. That will be equal to 4.5, negative 4.5%. You will see that there is a negative 4.5 here. That is negative 4.5. Just like here in our previous example, okay, this one, we have to multiply this to the power factor adjustment. Sorry, you have to multiply this by the total basic charge. Total basic charge. Okay, we already have the penalty and now the discount. Okay, negative 4.5% multiplied by the total basic charge. So the discount is 14,412.6 pesos. Okay, so let us have this illustration. You have 85% base here. That is 85%. So, you lower the power factor. One. So the power factor, you come up with a penalty. So this is 78.4%. So that is a penalty amounting to 11,578.7 pesos. But when you increase the power factor to 100%, you come up with a discount of 14,412.6 pesos. So you will see here, this one. Question, how much is your savings? How much is your savings? Sir, you say 14,412.6 pesos. No, that is not your savings. What is your saving? What is your total saving? Let's see. In this example, the total saving would be the approximate sum of the eliminated penalty and the realized discount, which is therefore 11,578.7 plus 14,412.6, and that total is 25,991.3 pesos. So meaning you have to add your penalty and your discount. Okay? This proves one of the benefits of the power factor correction through the use of capacitors. You see, this one, you have to add these two. So that is around 25,991.3 pesos. That's how big your saving is. That is your total saving. You reduce, you eliminate the penalty, the 85%. You eliminated the penalty and you increase the power factor. So you have a discount. See? So therefore, your total saving is the sum of these two. No? Nawalan ka na ng penalty, nagkaroon ka pa ng discount. No? Dahil tinaas mo yung power factor, you increase the power factor. That is the greatest contribution of power factor correction. Okay, let's take a look here. These are just some additional information. Okay, so we have can learn something here, no, from this formula. Percent reduction of apparent power. The percent reduction of apparent power. So we have here, let's say the corrected power factor over the original power factor. Let's say the corrected is 0.96, original, let's say 0.7 minus 1 times 100%. That is the percent reduction of apparent power. The percent reduction of power loss, that is 1 minus original power factor. Okay, let's say that is 0.7. And then corrected power factor, let's say that is 0.95, let's say. So, times 100%. The original power factor is the power factor without the capacitor. Okay, then when you put the capacitor, you already have your corrected power factor. And these are some power factor of the some common loads: lighting, induction motor, welder, electric furnace. These are just the approximate power factor of each loads. Here. Okay, so this is the kilowatt multiplier for determining the capacitor kilobars. No, actually, nowadays this makes no importance, no, because of the formula. If you have a scientific calculator, but if you don't have, that's very useful. So, what do I mean? So, the Q of the capacitor, here, again, the formula, the Q of capacitor is P of the load multiplied by tangent theta old minus tangent theta nu. So again, your theta old, that is your theta L, theta of the load. No? Your theta new, that is your theta T. This is without capacitor, this is with capacitor. See? So this is our basic formula. You see, for example, we have an example here. Let's say you have your QC that is 100 kilowatts. Then your tangent theta old, no, minus tangent theta new. Of course, no, let's say your initial power factor for this case, okay, so let's have this example. Okay, na natin. Let's copy this. From 65 to 95%. You see, 65% power factor. We can get theta L, let's say arc cosine 0.65. Okay? Then we can have theta T, arc cosine 0.95. Okay? One. From 65% to 95%. Okay, let us calculate this one. Okay, arc cosine 0.65 equals, so our angle here is 49.46. 46 degrees. Then, let's say, our cosine of 0.95 is 18.90 degrees. Let us make use of this formula. Make use of this formula. Okay, partner, can yes. Okay, so our Q of the capacitor. So we have 100 kilowatts. So we have tangent theta old is 49.46 degrees. And then minus tangent 18.19 degrees. I will get first the value inside the bracket here. One. What is the value here? No? The value in the bracket. So let us get first. We have tangent of 49.46 minus tangent of 18.19. So the answer is 0.84. That is 0.84. Take a look here. Take a look. You will see this one, this table, from 65% to 95% power factor. You will see here, this is 0.84 actually. Meaning the beauty of this table is that is the difference of tangent theta old minus tangent theta new. This one. Well, of course, still, that is very useful. Like, if you have this table, okay, especially if you have your job, no, in your work, no, you can make use of that table. But if you have your scientific calculator, you can manipulate, you can calculate the value. So, anyway, if you have that table, that's very easy, right? So, we have here QC is equal to 0.84, so 84 K bar. So that will be the value. No? That will be the value, 84 K bar. Okay? So let's take a look here. There. So these are some sample of the capacitor bank, no, being used. So let's say this capacitor bank is a modular type. You can increase or decrease the value of the capacitance. No? When you increase the capacitance, the K bar also increases. Remember that, no? So it's very important to know your load power, no, your kilowatt demand. No? So this is a modular design, make it possible to match the capacitor bank rating precisely to the needs of the customer. The capacitor bank is upgradable so that the initial installed rating can be increased to follow the growth of the company. You see? So there is still a saving here because if the load in a company increases, you just have to buy another modular, another sets of capacitor bank here. You will not replace the whole. You just have to add some capacitor banks here. Some capacitors. So, okay, that is the advantage. Okay, and by the way, sir, I saw a TV commercial. Is it true that this product, this energy saver, is true? No? I think that product is from Taiwan or China, no? Because the one demonstrating is a Chinese. No? It's a Chinese. Is it really true that? Is it really possible? Is it possible that the rotation of the meter decreases? Is it possible? The kilowatt hour meter decreases. So let's see. Let us discuss this. Say we have a transformer here. Let us consider first the resistance. From the resistance. Let's say this is our load. Okay. Let's imagine we have a transformer here. We have a transformer here. Then there are feeder lines here. Okay, let's say underground feeder line, there are resistance. Then this will go to the switchboard or switch gear here. Then this supplies different panel boards. There's a certain resistance here. So let's say there is a metering here. Let's say on the secondary side, the metering. That is our energy meter, the kilowatt hour meter. We call this as kilowatt hour, right? Kilowatt hour. Kilowatt is power. Hour is time. Power times time, that is our energy, right? That's why it is called as energy meter. So we have here the resistance. And the resistance. This is the feeder line, especially a long run in the commercial or industrial building. We have a long feeder lines. Okay, so by the way, what power is this? What power is this? I have to convince you first here. With respect to the utilization part, to the building, no? So these are the feeder lines. Okay. Let's say there are metering here and also there are some metering here. So let's say this is the main meter, secondary of the transformer. So what power is this? Is that power output or power input? That power is power input. Because that is on the input side. If we mean the output, okay, that is the power on the load itself. But if there is a feeder line, there is a power loss here. That is why power input is equal to power output plus power losses, right? The power output is the power at the load itself. It is absolute. If we mean power output, that is the power consumed by the load. Not included the power consumed in the line. No. Okay? So at the load only. That's one. So as you see here, this one, no? ISO, power output, power input. Let's go with the efficiency. Efficiency is power output over power input times 100%. No? Then another formula is power output over power output plus power losses times 100%. Let's take a look here on the current. Let's take a look on the current. For example, we have the current here flowing. One. We have a current here. Let's say this will be, this is the current here. The current here is current flowing IL. This is our IL 100 ampere. Just an example. Okay. Although this is a low value, no? One. Let's make this as 1,000 ampere. No, it's 1,000 ampere. So, where is that? We have here this one. This is our IL. Okay. That is our IL. Again, we've said that we can break down this one into two components. Here. One. This is our IL, right? We took this current from the utility company. Now, let us put a capacitor back here in parallel with the load. There is a capacitor back in parallel with the load. So therefore, there will be IC here, right? There is IC, the capacitor current, which is a leading current here, right? It is a leading current. Take a look here. This is a leading current. Let's say, let us project this size here. You can see this one. That is your I total. That will be, this is our IC. You will see that this is now our IT. If you put capacitor here, that will become your IT. That will not be any more IL, right? Kasi meron ka ng capacitor. You already have capacitor here. So our IT is IC plus IL, right? That will be. Okay. So you will see here that the current will reduce. Now let's make some basic calculation. What will happen? Let's say your IL is 1,000 amperes. I don't have the value for the resistance. Have the table for resistance value of this feeder line. So, one. So, whatever the value of this, no? Okay, I will just put here, let's say that is 0.01 ohm. 0.01 ohm, let's say. It's just an example. Any value of resistance of the feeder line will do. Okay. What's important here is the principle. I will put here the power loss without capacitor. Let's say without capacitor. We have said that when we put capacitor, the power loss is equal to, of course, the power loss is I squared R, isn't it? That is I squared R. The power loss is, what is our I? 1,000. 1,000 squared. Then multiplied by the resistance, which is 0.01. Let's see. What is the value? Let's calculate. 1,000 x squared 0.01. 10,000 is correct. 10,000 watts. 10,000 watts. That is the power loss without capacitor. But when you put capacitor on the line, power loss with capacitor. Let us call this as PL, power loss line. The current reduces. Obviously, the current reduces any value of IT, definitely that is lower than 1,000 ampere. You see here. Okay? You see this one. For example, you have 1,000, then let's say your IC is 200, say 200 ampere. We don't have an angle here, so let's just make an example here. So our IT is equal to IL plus IC. Let's say your IL here is 1,000 angle. Let's say we have 40 degrees. This is your theta L. Let's say you have negative 40 degrees. Negative 40 degrees. Plus, let's say 200 bar angle. Since this is 90 degrees, that is positive 90 degrees. Right? Positive 90 degrees. So you will come up with what? 1,000 bar angle. You have to go first to your complex mode. Mode 2. You have 1,000. Then we have negative 40 degrees because that is current is downward here. Then plus. Again, 1,000. We have negative. We have negative 40. Plus 200. Bar angle positive 90 degrees. Equals. Shift to 3 in my calculator so that get the magnitude. That is around 80. Can try this at home, no? 884. 884.81 amperes. Okay, forget about the angle, although that is around negative 30.03. This will be our IT. You will see here that the current is reduced from 1,000 ampere to 884.81. Definitely, the current reduces. From this vector diagram, you will see this one, right? It's being reduced. So, we have 884.81 squared multiplied by 0.01. So that will be equal to how much? What will be the power loss? 884.81 x squared multiplied by 0.01. So that will become 7,820.89 watts. You see, for any value of resistance, definitely from 10,000, it reduces to 7,800. That's more than 2,000 watts saving See, you reduce, no? You reduce the see, the power loss. Actually, power factor correction is loss reduction. It's a way of power loss reduction. It's not actually reducing the load current or load power. No, that is constant here. What is being reduced is the loss on the line. When you reduce the loss on the line, take a look here. When you reduce the loss on the line, of course, see, take a look here. You reduces the loss on the line. Okay. When you reduce the loss on the line, what will happen? See, you reduce the current, you reduce the loss on the line. The power input reduces also, right? Take a look here. Bababa ito, di ba? So, when you reduce the power input, take a look here, you reduce now the energy. Of course, when you reduce the energy, the kilowatt hour meter will be slower, right? It will rotate slower. So it is really possible. It's really possible. Okay? To reduce. Okay? It's really possible to reduce the energy consumption when you use the capacitor bank. Now, here is the problem. When a certain manufacturer of a residential energy saver consulted me, because there is still a more realistic vector diagram. Bubulgar ko sa inyo to. I will reveal this to you. So, this is a more realistic vector diagram than this. Than this one. I'll show this to you. This is a more realistic. Of course, this can also be power, right? No problem. No? They are just to say, so this can also be power. Can be current, it can be power. Okay? We can put this as QC, we discussed this before. It's QC, this is SL, this is ST, that is also QC, right? So you have your PL that is equal to PT. So you will have your QT here. This is the problem now. This is the problem. Especially those energy savers for residential customers. Because I discussed this is more of a commercial and industrial building applications. The problem here, when I saw that energy saving device for residential customers, this is the problem. Okay? This is the ideal vector diagram, but the reality is this one. If this is our SL, you see the ST reduce its value, right? But in here, you see this is our ST. The ST increases here. Why? Why it increases? Because, take a look here. The SL, you have your QL for a certain energy device. No? There is a capacitor present there, and then there are some circuit there, together with some electronic circuits. And this consumes real power. That is the problem. This is a pure capacitor. That is a pure capacitor. That is for pure capacitor. The problem is, if there is a real power being drawn by the energy saver, that also draws real power, this energy saver. We can call this as S of the, let's say, the energy saver or the capacitor. One. Of course, the SL still, you have your QL, you have your This is your PL, right? That is your PL. Take a look. This is the problem. So you have your QL here, QL. But if you have a capacitor that consumes also real power, this is the problem. You will have here your SC, so you will have here your PC, and you will have here your QC. This is your QC. The problem here, that is a portion of the capacitor PC. Therefore, the total power is not anymore equal to the load power. Before, the PL is equal to PT, but now the PT is equal to PL plus PC. You know, there is an additional consumption. This is a real power. The energy meter will read that real power, the kilowatt consumption of your energy saving device. That is the problem. Take a look at the vector diagram. The ST becomes greater than SL. It becomes a load. There's a possibility that this will increase your electric bill. It may not be effective. That is the problem. Possibility. It's a possibility. It depends on the rating of this device. That is the problem. So, this is an ideal vector diagram. Okay? Being used for commercial and industrial building, and even in distribution line, but not in residential. That is why that is no energy saver in residential or residential customers. This is the problem. Okay? Because this energy device may still consume real power. That's the problem. You see, the ST is greater than SL. That's a possibility. If that will become SL is equal to ST, what's the sense? No more sense, right? It should be ST must be less than SL so that there will be savings here, right? Okay, that's the point. Okay, so I think so that's the end of our lecture. Thank you, mga kawerpa. Salamat po. At sana kayo po ay may natutunan ngayong araw na ito. Maraming salamat po, and thanks be to God, mga kawerpa. Thank you.
Wait lang po. Wait lang po. Wala po muna mag-leave.
Okay, sound check. So please post your question here, no? So we still have a little time for our question and answer portion. So please put your question. If you have any question. Sige po, pakilagay lang po sa chat board, no? Please put your questions on our chat board, please. Okay, if you don't have any question, no, we can go directly to our marketing presentation. Don't have any question. Okay, kita na po ba yung ating audio and video? Is it clear? Please thumbs up lang po kung maliwanag po yung audio and video po natin. We have foreign nationals. Last time we have Malaysians, no? Students. Diyan ba yung Malaysia? Do we have non-Filipino participant for today? Please chat on the chat board. Kung wala naman, I can speak Tagalog na, no? Na tayo mag-Taglish. Actually, we are doing this free webinar in English version because we want to help also our students all over the globe, no? Not only Filipino students and practitioners, we also want to help our non-Filipino practitioners. Okay, we just recorded this lecture video just last Friday, no? So, nai-record na po namin yan last Friday lang po. Sige po, if you have any question, we are here to serve you guys, no? Hindi na kami nakapagsalang nung sample review lesson kasi lagi naman po kami nagsasalang yan at mas gusto sana namin na magkaroon tayo na lang muna for today ng live na Q&A portion. Sige po, pwede po kayo mag-type ng mga question nyo. Maganda sana kung in English, pero okay lang kung nakatagalog yan. Meron ba nagtatanong? Wala yata. Wala po bang magtatanong sa inyo? Wala po ba? Habang nag-Q&A, sana isend na muna natin yung yung sign up form. So isa-send po namin sa inyo, no? Hindi, mamaya na mamaya. Okay, wala po bang magsasend in ng question? Kung wala po, diretso na po ako sa marketing presentation po namin. Okay, so meron nang nagtanong dito, si Alfreds, no? Sir, tanong ko lang po, totoo po ba na pinagbabawal ng NGCP mag-install ng capacitor bank sa mga malls? I don't know with with NGCP. I'm not connected with NGCP. No? I worked before in consultancy and in construction. I can say anything. I can say anything about NGCP, no? But as far as I know, Okay? So as far as I know, even NGCP, they have capacitor banks in their transmission line. No? Even Meralco. Power factor correction is not a new technology. It is an old technology. No, hindi na po bagong technology itong power factor correction. No? Although marami kasi ini-ignore lang nila itong topic na ito, but it is a very important topic. This will talk about energy saving, about efficiency of the system, no? Ano ka-efficient ang system mo, yung palang makatipid ka sa kuryente, yan naman ang gusto ng lahat, di ba, no? I still have a lot of topics to discuss related to energy saving. Don't worry, no? And that's for free. We will give you that. No? Is Marte our no? Hello, Marte. No? Are you the no? Ikaw yung aming latest enrollee, no? Tama ba, Marte? Marte, nandyan, nakita ko. I'm Engineer Reggie, Kuya Reg Marina. No? Ako yung kachat mo nung isang araw. At salamat sa pagtitiwala. No? Don't worry, legit yung iyong enrollment with us. Engineer, no? Ngayon pala, tatawagin na kitang engineer. So, salamat sa pagtitiwala mo. Nag-avail kasi siya nung self-paced review program natin. Salamat, Marte. At every Sunday naman ito, everybody is welcome whether you are enrolled or not, no? Tayo lang po ang ganitong review center, I would say, no? And I am encouraging or challenging, tawag ng iba challenging, but not to challenge them, no? We are encouraging all professionals, no? Whether you have a training center, review center or not, no? Sabihin natin kahit professional kayo, hindi naman kailangan na may review center para tumulong sa kapwa, no? Kasi may mga ganong mga professional gustong magturo-turo, magbigay ng mag-impart ng knowledge. So we are encouraging everybody, no? Na conduct ng mga lectures na ganito, no? Lahat ng professional, no? So kilala nga akong professional imbis na mag-lecture nagti-TikTok lang no. Pasayaw-sayaw, no. Okay naman 'yon, no. Masaya, no, entertainment, no. So, engineer nagti-TikTok, puro 'yun ang ina-upload niya sa kanyang maganda mag-upload din sana siya ng lecture, ng mga lecture kasi marami na talino 'yun magaling mahusay na tao yun no. Anyway, di naman niya tayo kilala, no. Mas achiever naman yun kaysa naman sa amin, no. We are not that as achiever as he is, no. Kasi nakakatuwa lang makikita mo nagti-TikTok, naggumigiling-giling, sumasayaw-sayaw, no. He is a isa sa yan. Professional yan, no? Engineer yan, engineer. Oo. So, sana kung paano, okay lang yung TikTok, masaya yun, no? Masaya, no? Pero sana maganda yung mga ganyang klase, magturo din, yung mag-share, no? Mag-share, no? Tama ba ako? Thumbs up naman kung agree kayo doon sa sinasabi ko. Thumbs up nga kayo. Di ba? Imbis na magsayaw-sayaw ka dyan, ikaw nga yung maraming alam, magturo ka kasi ang daming kailangan aralin, nakala nyo. So many things to learn, no? It doesn't mean we are already engineer, alam na namin lahat. No, no. It's a continuous learning. You should study every day, no? See to it that every day you're learning something with your profession. You are reading, continuously reading. If you can't read, you watch in YouTube. That's something that you can enhance your technical skills. So it doesn't mean you are already a licensed, you will stop studying. No, no. It's not a good idea. After that, you're doing some TikTok. It's okay, but you should combine that with your sharing your knowledge also. Yung TikTok lang. Wala akong nakitang lecture niya TikTok lang. No? Siguro kung maririnig niya itong sinasabi ko, baka gumawa na ng lecture. No? Pero wala naman po akong binabanggit na pangalan sa inyo ha. Wala akong binabanggit na pangalan kung sino yung engineer na yun ha. Oo. Kasi nakita ko parang ano lang, TikTok lang eh. No? So, mas maganda sana how I wish na mas dihamak mahusay na tao sa akin yun eh. Talagang achiever yun eh. No? How I wish sana na meron din siyang mga video about lecture, tuturuan, ano, tuturuan tayo, no? Kasi mas senior sa akin yun, talagang biro mo, mas may edad sa akin ata, ano. I'm not sure, ha. TikTok. Dapat ano, mag-share tayo ng knowledge bilang engineer, no? Yun dapat ang gawin natin, hindi okay lang mag-TikTok, parang additional spice yun eh, no? Kumbaga sa pagkain, side dish lang dapat yun. Dapat ang main dish mo talaga is to impart knowledge. No? So kasi TikTok, dami na nagti-TikTok eh. Gaganda pa, di ba? Di ba? Tapos ikaw, laki-laki ng tiyan mo, pambira, magti-TikTok ka dyan. Di ba? So, mas maganda yung ating ano ay gawin na lang nating ano, di ba? Mag-impart tayo ng knowledge sa ano. Halos everyday yata nag-upload ng TikTok niya eh. Okay, anyway. Makikita nyo kung sino yun, kung kayo yung impart sa mga electrical group, sa mga ano, no? Makikita nyo yun. No? Pero magaling, galing gumiling, galing gumiling niya siya. Pero sana ano, okay lang 'yun. Hindi ako against doon, pero sana mag-impart din ng knowledge. Okay, tuloy niya lang yung pagti-TikTok na sayaw, no? Pero mas maganda mag-impart din ng knowledge kasi maraming mai-impart na knowledge itong taong ito eh. No, yung engineer na ito. So ayun. Tulong-tulong tayo para magkaroon ng knowledge ang ating mga estudyante, no, at yung mga practitioners. Marami pang kailangan matutunan, alam nyo. Ako'y nakakilala ng isang PEE. Top 1 po siya sa associate electrical engineer, tsaka PEE licensure. Both top 1. Consultant po siya dati ng Saudi Aramco, ng maraming company dito sa Pilipinas. No? Pero pag nakausap mo siya, parang feeling niya tuloy-tuloy pa yung pag-aaral niya. Feeling niya kasi konti pa yung alam niya, gano'n. Sinabi niya sa amin yun na dapat yung pag-aaral tuloy-tuloy yan. No? Biro mo siya nga matanda na, that time 70 years old na siya noon. Imagine nyo, 70, ngayon 80 na yun. No? But he feels na hindi pa ganun karami yung alam niya. He's too humble, a very humble person. No? So how I wish na ganun ang maging marami, no? Karamihan. No? So, meron kasi konti lang yung alam mo dami ng alam. Di ba no, Sir J. Paz, ano? Tama ba ako, J. Paz? Parang familiar ka sa akin, Sir, ha? Meron kasi konti lang yung alam eh. Meron nga walang alam eh, pero he's pretending ang dami niyang alam eh. Alam ko na po yan, ako po yung magdedebo 50 anyos na. Nakasagupa na po ako ng mga ganyan technical people. Alam mo, daming alam. Wala naman pala, no? So, mas maganda na yung you feel small but your brain is large. No? Mas maganda na po yung ganoon. Sige, wala na bang tanong? Sandali, hindi ko pa yata na kompletong sagutan to. Totoo po ba na pinagbabawal ng NGCP mag-install ng capacitor bank? O sinagot ko na. No? NGCP, Meralco, transmission, kailangan kasi nila ang capacitor bank. Hindi naman bagong technology yan. Kasi even sila kailangan mag-save. Kasi hindi lang to save, to increase efficiency para magkaroon ka ng efficient system. Actually, itong power factor correction, ito ang pinaka-paborito kong topic sa lahat ng webinar ko, na seminar ko na. Kaya ito inuulit-ulit kong i-lecture kasi maraming makikinabang dito. Alam ba ninyo kayong mga batang engineer o yung mga aspiring engineers and master electrician, you can be rich with power factor correction, no? Kahit kayo na lang, no? Kasi may kilala akong nakita ko yung engineer ang calling card niya nakalagay, Energy Saving Consultant. Ang ganda ng title niya, Energy Saving Consultant. Kumbaga, consultant siya ng mga kumpanya. Isa sa kanyang trabaho ay nagkakabit sila ng mga capacitor banks. Yun ang deal nila, no? O, pag di kayo nakatipid, huwag niyong bayaran. Kukunin na namin yung equipment namin within 6 months. Ganda, di ba? Ganda ng kanilang deal, no? Walang bayad, no? Sa inyo lahat ng savings, pero pag within 6 months nakatipid kayo, bilhin niyo na tong capacitor bank namin, no? Babayaran niyo na to. So, ayun, nakakabenta siya. Tapos siya ay nagbibigay ng consultancy sa mga company para kung paano makaka-saves ng energy. No? Ang ganda ng kanyang trabaho. No? Konti lang yung ganon. No? Isa yan sa pwedeng maging specialization ng mga young engineers. No? Pag nakapag-experience na kayo sa kumpanya, no? God willing, you can have your own company, can be like that. No? He is a contractor. Of course, you can't do that if you are in a company. No? You should be a contractor before you can do that, to be an energy saving consultant. He is a contractor. So, wala na po ba kayong tanong? I can answer 100% kung ipinagbabawal NGCP pagdating sa mall. Let's say direct yung isang large customer, hindi na kumabit kay Meralco sa utility, diretso na sa NGCP. Hindi sila pumapayag. In behalf of NGCP, it's unfair, no, that I will answer a tentative answer for this. I don't know kasi hindi ako working sa NGCP, pero kasi ang NGCP, siguradong may mga capacitor banks yan along the line. Mga static bar compensator, mga harmonic filters, no, may mga capacitor yan. Yun lang harmonic filter. Harmonic filter yon, pero meron na ring harmonic filter na hindi lang pang filter ng harmonic or power factor correction na rin ang purpose. So, even sila nagpa-power factor correction ng NGCP. No? So, totoo po ba pinagbabawal ng NGCP? Siguro na lang ang masasabi ko rito, in my opinion, no, my professional opinion for this. I don't think so na ipagbawal nila yan. Una, sila mismo gumagawa niyan. Alam niyo na pag pinagbawal yan, no? That is for business reason. Para malaki bayaran mo sa amin. Ang hirap kong sagutin yung mga ganitong tanong, may halong political issue, no? Sige, next question. Baka maano tayo. Lalo na medyo lumalaki yung YouTube channel natin, partner, no? Oo, 13,000 na yung subscriber natin, tapos kalahating milyon na mahigit yung nakakapanood ng mga video natin, no? Mahirap na, no? Pero in my honest opinion, hindi, kung pinagbabawal nila, hindi dapat sila mismo nagpa-power factor correction. Tsaka pag nag-power factor correction ang customer, pati yung may na yan, tawag diyan, meron ding benefit sa kanila yan, no? Pati sa utility side, no? Sa NGCP side, pag maganda ang power factor ng customer, that will talk about efficiency kasi no, efficient, minsan mas maganda yung sistema, kumita ka nga, no, after some time. No, nagka-problema sa system mo, nag-low voltage, nasira mga equipment, no? So, kasi alam nyo, if we mean efficiency, high efficiency system, isa sa indication yan, maganda voltahe. The quality of power means also the quality of voltage. If you have a good volt, because current is constant, kinukuha mo kuryente. Kinukuha mo yung kuryente. But voltage is variable. Pag mas marami ka, load ka ng load ang voltahe tends to decrease. Pag nagbabawas ka ng load, voltahe tumataas. No? So, maganda rin ang effect pagka nagpa-power factor correction ang customer. Maganda rin po yan. No? Nakakatulong ka rin pati sa utility. Maganda ang system mo, magandang voltahe mo, swabing-swabe lang, hindi mataas, hindi mababa, tama-tama lang. Efficient yung system mo. Continuous supply, regulated, maganda, no? So, pag pinroject mo siya on the NGCP side, utility side, no? May benefit din sa kanila yan. May benefit din sa kanila yan, no? Mababa power factor mo kasi hindi ka nag-power factor correction. Eh, di mas malaking kuryente kukunin mo sa source. Oo, kikita sila ng mas malaki dyan, no? Siyempre, yun ang number one reason dyan. Negosyo yan. Eh. Kaya huwag kayo mag-power factor correction para hindi kayo makatipid. Malaki babayaran nyo sa akin. Di ba ganun yun, Al Prince, ano? Siya kasi nagtanong, kaya natatawa si Al Prince. Eh. So, naintindihan mo ba yung ibig ko sabihin, Al Prince? Tatawa si Al Prince. Ayun. No? So, satisfied ka ba dun sa sagot ko? Ayoko nang dagdagan na. May halo politika kasi. Medyo delikado, no? Okay? Naka-YouTube live pa tayo, tsaka Facebook live. May mga nanonood sa atin, no? Okay. Subscriber ka ba namin, Al Prince? Hindi pa, subscriber na. Sige, download mo na yung... May nagtatanong kasi, Sir, asan ba yung 200 plus na libreng video nyo pag umattend ng webinar? Ayan, yung YouTube channel. Nasa YouTube channel. Saan po yung 200 plus na sinasabi niya sa advertisement nyo na pwede namin i-download? Nasa YouTube channel na po. Inyo na yan, download nyo. Original po lahat yan. No? Tayo kahit maliit na review center, tayo lamang po ang may ganitong klaseng YouTube channel. Paki-chat nyo nga po sa chatboard kung may nakita kayong review center na katulad natin. Paki-correct nyo po ako kasi baka mademanda ako. Eh. So, nahirap na. Diba partner, no? Willing akong i-demanda kung mapamalian nila itong sinasabi ko. Eh, no? So, pero nasisigurado ko kami lang yung ganitong review center na may ganyan, sandali na may ganyang kadaming video. No? Maaring merong YouTube channel yung ibang review center, pero hindi ganun kadami yung uploaded video. Pero, ang challenge ko, yung may ganyang kadaming video. May pre-webinar, linggo-linggo may pre-webinar. At abangan nyo, no, magpo-post po kami no, ng scholarship program next week. Magkakaroon po tayo ng libreng review sa mga less fortunate nating mga kababayan, no? Yung mga gustong mag-review pero wala silang perang pang-enroll, no? So, welcome po kayo. Yung mga nawalan ng trabaho o kaya na-lay off sa trabaho, isang beses lang, 2 beses lang ang trabaho, no? Eh, sakto-sakto lang yung kinikita sa pamilya, kulang pa. We are willing to help dahil ang UN Television po ang ating major sponsor sa ating review program na ito. Scholarship program po ito. No? Ina-advance ko lang. Next week, ipopost po namin yung advertisement namin na yan. Ano po? Ipopost namin. Okay, sige. Alpring, satisfied ka na ba dun sa sagot ko? Ang haba nung sagot ko O, tama na yun siguro pwede na yun. Sige. Alam mo, meron tayong magkakaroon tayo this November. Abangan nyo po. Weekday nating gaganapin. Mentoring program. No? Q&A portion yun. Pero ang sistema natin doon ay ipapadala nyo yung mga ipapadala nyo yung mga questions nyo and then para ma-prepare namin yung mga answers and the presentation, no? Anybody, no, hindi kailangan ng estudyante namin, no? Kahit estudyante namin o hindi, kahit sino pong electrical students and practitioners, you may send question to us sa aming messenger account, no, yung Marinais Powerhouse. Then sasagutan namin po yan, ano, pagdating ng mentoring program. Abangan nyo po yan, maganda po yung mentoring program namin, ano. So part yan actually ng review program namin, pero ino-open po namin sa public yan, no. Libre lang po yan. Sige, may mga questions pa dito o concern lang ito. Ask ko lang po sir, sabi ni Marte, no, yung estudyante natin, ask ko lang po sir, gaano po katagal ang life expectancy ng capacitor bank? After po ba nun, need na palitan lahat? It depends on how you have your maintenance program, no? Tanong mo sa supplier, how can this be maintained properly? No? Depende yan sa supplier, tanungin mo sila. Based from my knowledge is more or less 10 years. Pwedeng tumaas, pwedeng bumaba. No? More or less 10 years tumatagal yung mga capacitor bank. May napuntahan kaming isang industrial, no? Ito cold storage building. 15 years na raw yung capacitor bank nila. 15 years. No? So, depende. Depende sa load, paano mo siya gamitin, ano? Depende yan. Okay. Tumatagal din ang capacitor banks. No? Eh, may mga capacitor bank, pag in-overload mo talaga, sasabog yan. Sira agad yan. So, pag hindi mo siya ginamit properly, of course, you have to consult your experts, no? Yung expert din sa capacitor, yung mismong supplier or sales engineer or application engineer, you have to ask them how can it be maintained, how to use it properly. So may mga catalog yan, may mga specifications, no? Kumbaga para kang bumibili ng TV na may manual yon, no? So meron yan para magamit mo siya properly, no? Okay. Okay na yan, Marte. Okay, yan. So wala nang nagtatanong, wala na. Kahit isa pa. Wala na po. Anyway, sige, kung wala na pong magtatanong, pupunta na po ako sa marketing. Partner, ano ba ito? Ano natin? Salang na natin yung marketing natin. Okay, wait lang po Okay, please take a look at our marketing presentation. So, here's the name of our review center, MPHT Review and Training Center. Marinais Powerhouse Team Review and Training Center. Gusto mo tutukan, mag-powerhouse ka na. Because the power is in the house. So that is our slogan. This free webinar is brought to us by UN Television and IIEE. So every Sunday po ito, 1:30 to 5 p.m. po. Kasi may klase na po kami ng 5 p.m. So hanggang 5 p.m. lang po tayo. Ito po ang ating YouTube channel. Kung hindi pa po namin kayo subscriber, so please do subscribe at Reggie Marina YouTube channel. Please like and share. Then baka po pwede po panoorin niyo na rin po yung kaunting mga commercials po diyan sa ating pong channel. Segundo lang naman po yan. Yan. So may da-download niyo po ang mga videos na yan. Okay, as of today, ito yung galing po sa YouTube, hindi sa amin. Ang amin pong subscriber, sabi sa YouTube Analytics, sa kanila galing ito mismo, hindi namin invento ito. So, alam ito ng mga YouTuber, alam nila to, yung mga nag-YouTube. So, pag pinindot nyo yung Analytics, ay lalabas po itong subscriber, ay nasa 13,200 plus. Ito pong channel namin ay 2 years pa lang, 2 years pa lang po itong aming, since pandemic lang po ito. Your channel has gotten 536,049 views so far. As of October 30, 12 noon lang po ito. Yan, so more than 500,000 na po ang nagtitiwala po sa ating mga lectures. Sana tuloy-tuloy lang po. Salamat. And we are inviting you to be a member of our private group, MPHT Review Center. So far, we already have 3,600 members. We have an early bird promo, baka may gusto pong humabol para po sa aming online review via Zoom, for April 2023 RERNE board exam and February 2023 Master Plumber board exam. So, may nagtatanong, sir, electrical ako, pwede rin ba akong mag-take ng Master Plumber? Yes, pwede. Actually, I am also a Master Plumber. I am at REE license and the Master Plumber license. So, pwede po tayong mag-take nitong board exam na to, Master Plumber. So, ang kagandahan nito, pagka naipasa nyo to, para kayong PEE, pumipirma ng plumbing plan ito. Kung magkano yung electrical plan, halimbawa 2,000 per sheet, 2,000 din ng ang plumbing. Hindi po nagkakalayo ng presyo yan. So, if you are interested sa ating online review course via Zoom, okay? Ang Master Plumber po natin ay only 5,000 pesos. Master Electrician is 4,000 pesos only. Then for registered electrical engineer is 6,000 pesos only. So separate po ang payment ng ating refresher course if you want to avail. So, pero itong review course is complete subject na naman po ito. Kung ano yung mga subject na kailangan, nadi-discuss na rin po namin dyan. So, extended po yung aming promo hanggang November 4, this Friday, our last extension na po ito. So, pwede po bang mag-enroll kahit estudyante pa lang, mag-review na para at least may idea na kami? Yes, pwede po. Kahit sino pwede na pong mag-review, yung mga electrical students and practitioners, graduate man kayo o hindi, pwede na po kayong mag-review kung gusto po ninyo. Maganda nga yan, ina-advance nyo na kahit hindi pa kayo mag-take ng board exam. Sa napakamurang halaga lang naman, makikita mo na ang kabuuan. At kahit sabihin natin, next year ka pa mag-take, 2 years from now, 3 years, even 5 years from now, hindi po masasayang yung ma-attenan nyo. Kasi tinuturo natin yung mga past and possible board questions. So makakatulong po sa inyong mga ito. Meron din po tayong tinatawag na self-paced review program. Yan, ito yung in-enroll mo, Marte. Aware pa natin, no? Aware pang Marte. Ha? Okay, mga aware pa na kayo, mga certified aware pa na pagka kayo nag-enroll sa Powerhouse. No? So, April po ito, RE, and Master Plumber. Meron din tayong review anytime, anywhere, any number of times pa pwede po kayong review. No? Ito ay applicable ito sa napakaganda nito sa mga nagtatrabaho, OFW, seaman, o kaya naman mga sobrang busy, no? Contractor, no? Mga businessman. So, makakatulong po ng malaki sa inyo itong aming self-page, no? We have a webinar series with e-certificate and free original videos. 249 pesos per copy. Kung hindi niyo po na-attenan yung mga previous free seminar namin, free webinar, there are 33 topics to choose from, no? So, 33 topics. Ang dami niyan, no? So, ayan po yung mga different topics namin, ano. So, if you are available, no? Pwede po, no? So, nga pala, next meeting, plano ko pong mag-lecture, no? Nag-start na po kami last Sunday. We started the English version. Simulan na po namin ito, puro English version na po ito. Kasi ako, paniwala ko naman, kahit naman na mag-English ako, minsan English Carabao lang naman ito. Kaya-kaya nyo naman masundan ng mga Filipino students and practitioners. Ano? So, maintindihan nyo pa rin. At mababaw lang naman ako mag-English. You know? So, yun lang naman kasi ang kaya ko talaga. So, iba kasabihan pag magaling daw sa math, hindi naman din ako magaling sa math. Iba kasabihan, pag magaling daw sa math, mahina sa English. Pagka magaling sa English, mahina naman sa math, no? Bata pa lang ako, naririnig ko na yan. High school pa lang ako. So, next meeting, our topic, it would be, I'm planning to discuss short circuit calculation in English version. Kasi somebody, an Indian national student, nagre-request siya, do you have an English version of your short circuit? It seems to be interesting the way you deliver the lecture. Your approach is quite different compared to my other professor here in India. Sabi niya. So, are you Indian? Because you look like an Indian. Padaw akong Indiano, sabi. So, no, I am a Filipino, sabi ko sa kanya. So, next week, no? Kung hindi nyo pa napanood yung pero I'll try my best. No? I will make it better this time. I conduct a short circuit calculation. Okay, I will improve that. But ang maganda dito, English version siya. But don't worry, no? From time to time, nagtatagalog din naman tayo. No? Kaya lang ang base language ko this time talaga, English. Kasi gusto natin matulungan din yung mga students and practitioners all over the globe. No? If it is possible, no? Gusto natin matulungan din po sila. No? Yun lang po ang aming purpose, no? Makatulong. Because that's what we believe in. Makatulong kami and everything will follow. No? Yun lang po yan. Everything will follow. Na our intention is to help. Number one is to help. Secondary, kung kikita man tayo, may panggasolina tayo, thank God for that. Ano? So mag-enroll man kayo at hindi, itutuloy po namin itong mga free services namin. No? Huwag po kayong mag-alala. Sa mga walang pera, walang pang-enroll, ito yung review center para sa inyo. No? Dami nga nagpasalamat, partner, doon sa ating YouTube channel. No? Kasi nakapasa sila sa board, nakatulong daw yung ating mga nai-upload na video sa YouTube channel pagpasa nila sa board exam. Ang masasabi ko po, opo, may tulong po yan, pero iba po yung mga videos o lectures namin sa mismong review. Halimbawa sa EE, hindi naman po kumpleto yun. Wala nga masyadong math ESAs dyan. No? Hindi naman marami yung math and ESAs subject dyan. No? Sa RME naman, hindi naman ganun kadami yung technical subject, yung PEC. Parang mga patikim lang po yung mga nasa YouTube channel namin. So kaya wag niyong isipin na kumpleto na yan. No? Kasi may nagsabi daw na may YouTube channel naman yan. Diyan na lang kayo. Libre pa. No? Tapos sa amin na lang kayo magbayad. Yun lang. No? Yun pala. No? No? So, ba't
mag-enroll kayo dyan, may YouTube channel yan. Kita nyo na yung lecture niya sa YouTube channel niya. Sabi daw, no? Kasi sabi sa akin ng isang estudyante, ay mali po yun, no? So, hindi po kompleto yung ating nasa YouTube channel, no? Mga patikim lamang po ng mga lecture videos yan. Okay. Iba po yung mismong nasa review na kayo, na naka-enroll kayo, no? Mas marami po yung video. Kung 300 videos yung pwede nyong i-download, no? Yung mga nakatabi namin, siguro mga 500 plus. Ganyan kadami, no? So, hindi namin nilalagay sa YouTube channel kasi that is for our part naman, part of the business na yan. Ginagamit namin sa business na yon, no? So, yung YouTube channel is to help, no? Patikim, no? Kahit paano, hindi ka zero, at least meron, di ba? So, yun po yan, ano? Pero sabihin mo, kompleto na yung nasa YouTube channel, tapos sa inyo na lang mag-i-enroll, hindi na sa amin. Iba yun. No? Walang ganon. So, tayo po may mga special webinar, no? On building wiring installation, industrial motor control, practical electrical design, electrical estimation course, meron din tayo niyan. Engineering math with calculator techniques, no? Mga self-paced po ito lahat. Ibig sabihin, you can study anytime, anywhere. So mag-message lang po kayo sa amin kung saan kayo interested ng mga products and services namin, ano? So mag-message lang po kayo. Meron din tayong special webinar, How Does an Electrician Become an Electrical Engineer in Just 1 Year through CHED ETIA program. Ito po, magkakaroon po kami ng not only special, a very special webinar every Monday. Abangan nyo po yan. We'll start on, balak sana namin, kung hindi November 7, November 14, every Monday po. Live po na special webinar para yung mga technicians na gustong maging engineer in just 1 year, mag-aaral ng ETIAT, no? Na-research ko na sa internet kung anong bakasyon, no? Executive order, no? Executive Order 330 ni President Fidel B. Ramos, no? Kasi kalokohan daw yan, hindi raw totoo yan, sabi ng isang engineer, no? Kami nga 5 taon nag-aral yan, 1 taon lang, paano nangyari yan, no? Kalokohan yan, ikaw ang kalokohan, hindi ka nagre-research, no? Tingnan mo ang Executive Order 330 signed by President Fidel B. Ramos. Inaprubahan niya po yan. Lahat ng mga electrician o technician na gustong maging engineer, no? Pwede, 1 year lang. Basta may requirement, syempre, no? At least 5 years. Doon sa school na yon, no? Na pag-aaralan nyo. Okay? So, kausap po nga yung isa sa nila, official nila doon sa school. Palalawakin pa po namin ito. Antabayanan nyo po, no? Yung mga electricians natin, yung may mga mas matataas na pangarap, no? Hindi lang electrician tayo habang buhay. Ina-encourage namin kayo na maging electrical engineer dahil isa yan sa solusyon ng ating kahirapan na nadadanas, no? Especially in our country, no? Sabi nga ng ating pambansang bayani, si Dr. Jose Rizal, no? Na-refresh ko yung No Limit Tangere, kakapanood ko nung ano yan, the DNA. No? Si Ibarra at si Clay, si Maria Clara, di ba? Sabi ni Jose Rizal sa kanyang No Limit Tangere, no? Binanggit ni Crisostomo Ibarra yun eh. Pero actually si Crisostomo Ibarra, yun yung karakter ni Rizal. Ginawa niya. Edukasyon ang solusyon sa kahirapan. Totoo po yan. No? Isa po, maring hindi lang yun ang paraan. Pero isa yan. Siyempre, nasabi yan ni Rizal noong panahon nila na maraming hirap. Kaya nag-aral si Crisostomo Ibarra. Diba? So, 7 taon siya sa Europa. Diba? Updated ako dyan eh. Araw-araw ko pinapanood. No? Pansa ko ni Okay. So, kung gusto nyo po na mag-avail ng ating special webinar na ito. No? So maaari po kayong mag-avail niyan. Yung aming pong live, gagawin namin a very minimal cost, 249 pesos. Imagine mo, no? Para malaman mo po ang detalye niyan. Hindi namin ma-explain ng details eh. Gusto mo malaman mga requirements, ano ang dapat gawin, do's and don'ts, ano yung kailangan i-prepare, no? Paano ka magiging electrician ka, high school graduate electrician ka, no? Kumbaga, feeling mo, yun lang yung narating mo, high school graduate ka lang, electrician ka, pero 5 taon na mahigit experience mo, no? Di mo alam, pwede ka pa pala maging electrical engineer. Ayan, tutulungan ka namin. No? Diyan kami papasok, i-assist ka namin. No? So, pagdating sa board exam, matutulungan kayo ng ating review center. No? Pagdating naman sa pag-aaral ng BSEE, andito po. No? I-discuss ko po, babanggitin ko po sa inyo ngayon kung saan yung eskwelahan na yan na nag-o-offer ng 1 year lang ng electrical engineering course. Okay, at katulong natin si Engineer Joel Elige na dati naming estudyante, no? ETF BSEE Mentoring Private Group, mag-member po kayo sa kanila, no, kung interested din kayo. Tuloy-tuloy yung kanyang pagme-mentor, pag-guide sa mga electrician o technician, o yung mga undergraduate, no? Kahit hindi electrician, yung mga undergraduate na gustong mag-aral ng BSEE. Ayan ang pangalan ng eskwelahan, ang Manuel S. Enverga University Foundation. Ayan din po ang kanilang FB page, ang website nila. Do you want to get a college diploma in 1 year? Nalaman ko kasi ito sa mga estudyante namin, yung mga nag-review sa amin before. No? Pumapasa sila, no? Biro mo, 1 year lang nag-aral. No? Tapos ang pasok nila doon, Sabado at Linggo lang. Ha? No? Kaya kahit nag-aaral ka, pwede ka. No? Napakaganda po nito. So, it's a very good opportunity sa mga technicians natin. Kaya hindi pa po tapos ang inyong pangarap. No? Kala ko, wala na kasi ano na ako eh. First year lang ako nun sa BSEE, tapos nag-electrician na lang ako ngayon. Yung pala, meron pa pala akong pag-asa. No? Meron pa, George. Huwag ka mag-alala, George. No? Kakatulong mo kami. Bibigyan ka namin ng pag-asa. No? So, at ng Enverga University. No? Ayan. Sila po ang makakatulong po sa inyo sa pag-aaral ng BSEE. Kami naman po ang makakatulong sa inyo sa pagpasa ng board exam para makakuha ka ng lisensya. No? Ayan, sa RME at sa REE. Meron din tayong special webinar. Halimbawa, lisensyado ka na. Pwede ka rin mag-attend dito sa aming special webinar on how to become a certified ship electrician and an electrotechnical officer. Kung mga gustong magbarko, welcome po. May experience man o wala, high school graduate, engineering graduate, pwede. No, welcome po kayo. Si ETO Virgilio Daniel, yung nakita niyo sa video marketing namin kanina. No? So, siya po yun yung ating in-interview. No? So, siyang ETO, RME, at graduate na rin po siya ng ETIAP, no? Take din po siya ng bilang natuloy po yung pagte-take niya nung nakaraan. So sa kanyang REE board exam, no? Sa Enverga University rin po siya graduate. Ito po ang aming mga REE books, no? Original po lahat 'yan. Baka gusto niyo bumili itong REE books namin. Ito yung ilang sa mga customers na nagtiwala po sa atin. Okay po. RME books, ayan. So, baka ano po kayo, gusto niyo pong bumili ng ating mga RME review books. Per set po ang aming pagbebenta nito. 4-4 po talaga yan. Ayan, baka interested po kayo. Pag-message lang po kayo sa aming messenger account. Okay, even Master Plumber books, meron din po tayong ino-offer. Ayan. Ito po yung naganap na contract signing last November 4, 2021. Ayan po. With IIEE, no? It's a multi-awarded organization po ang ating organization. With the help of Engineer Alan Alvarez, no? Ang ating National President. 2021, last year siya po ang presidente. Kinontak niya po kami at interested silang makipag-tie up po sa amin. Ito, at nagkasundo naman po kami, nagpirmahan kami ng kontrata. At ito po ang inyong lingkod at ito naman ang ating presidente last year ng IIEE, si Engineer Alvarez. Mismo ginanap po ito sa headquarters ng ng IIEE. Ayan po. Nakaka-aware pa ang contract signing na naganap, no? Ito po yung mga professional electrical engineer for your information, ano. So, hindi mga basta-bastang inhinyero yung mga yan, mga bigating engineers yung mga yan, no? At tayo naman ay hindi bigating, ano. So, sakto lang ito ang, no? Pero nagtiwala po sila, no, dahil nakita po nila yung ating YouTube channel, no? At ako'y nagpapasalamat, no, sa YouTube talaga. Nagkaroon kami ng maraming opportunities dahil sa YouTube channel. So, salamat. No, isa to sa benefit na nakuha namin, ano. So, ang ating 2022 president po, yung latest ngayon, current president, si Engineer Feliciano Padua III. Ito po siya, yung naka-red mask, no. Yan, nag-post pa siya sa kanyang personal FB account, kita niya naman. Hawak niya yung mga libro natin, ano. Train, CPD, Marinex Powerhouse Team Review Materials for IIEE Library. Yan, nasa library na ng IIEE ang libro natin. Ang tawag po sa amin ay IIEE UID partner, no? So, ang tawag dito ay Universal ID. Kung meron kang Universal ID ng IIEE, makakakuha ka ng 10% discount, additional discount sa ating review program at sa ating mga special webinars, no? May discount ka makukuha. Ayan. So, punta lamang po kayo doon sa Cubao, no? Or mag-message kayo or mag-inquire kayo sa kanilang website, no? iiee.org.ph, no? So, ayan. 200 pesos lang po yan, kung kayo ay BSEE or technology graduates, no? Students, graduates, welcome po kayo dyan, ano? Ito po ang ating Presidente, 2021 President at ang latest, no, President natin, current President natin, ito po si Sir Padua. Ayan, nickname niya si Sir Jojo, no, kung tawagin siya sa IIEE, si Sir Jojo. Ayan po kaming tatlo. Okay, tanggalin daw ang mask, sabi ni Sir President. Ayan. Ayan po at thank God at tayo napagtiwalaan, ano, napagtiwalaan ng mga dekalibreng mga inhinyero, no. Nagtiwala ang ating national organization, no? So we really thank God for this, no? Okay, promote ko electrical products mo. So inaanyayahan namin lahat ng electrical suppliers, no? So let us update our practitioners and students in the latest trend of electrical technology. We're inviting you to present your product, no? I'll be the one to present your product on a live audience, no? So, iaano po natin yan. Ipe-present natin yung produkto mo. I-discuss ko po yung technical side, yung marketing side. Pwede nyo pong i-discuss, no? So, pwede rin kayo mag-discuss even yung mga iba pang technical side, no? Pwede po, pag-usapan po natin. Gawin natin siyang pre-webinar. Libre lang, no? So, ang i-discuss natin yung mga latest product. Halimbawa, produkto mo, lightning arrester. Discuss natin yan, no? Maganda yan. No? So, binatutulungan pa natin yung mga estudyante natin, di ba, no? Alfreds, no? Tama ba yan, Marte? Di ba? Libre lang, free webinar, no? Yung binebenta mong produkto, i-discuss natin. Tapos, bibigyan ka pa namin ng oras para i-promote mo produkto mo. Biro mo, saan ka pa? Nakatulong ka na, kumita ka pa, di ba? Marami rin sa ating mga subscribers are already professionals, no? Hindi mo alam, baka contractors, managers na yan, mga yan, no? Di sa'yo nakukuha yan ng mga produkto, no? So, libre lang, no? Ipe-present natin to sa pre-webinar namin, ano? So, itong ating webinar, libre lang to, no? Ipe-present natin yung produkto mo, bigyan ka namin ng oras. Okay? So, kung interested po kayo, yung mga suppliers, ano? So, di na rin naman po biro, no? 13,000 subscriber and more than 500,000 views ang ating pong YouTube channel. Kaya marami pong makakakita niyan yung inyo pong mga electrical products, no? So pwede po kami maging katulong nyo as your marketing arm also, no? Po pwede po. Okay? So with this, I should say thank you mga kawerpa. Maraming salamat po. At sana tuloy-tuloy lang every Saturday, every Sunday ang pag-attend po natin. Thanks be to God mga kawerpa. No, we'll see you around. Okay? So live na po kami sa YouTube Live. No? At yung Google Form po sa mga nasa Zoom class, ang tabayanan nyo lang. Nandyan na ba? Nandyan na, no? Nandyan na po yung link. Paki-check nyo lang po. Fill upan nyo na po, no? And then, paglilib na po kami sa ating YouTube Live, Facebook Live. Salamat po. God bless, mga kawerpa. Pwede na po kayong mag-leave. Yung mga tapos po mag-fill up, leave na po tayo. Ituloy nyo na lang po, pakisend na lang po. Mag-leave na po kami.